Good morning, everyone. Thank you so much for joining us this morning. My name is Elise Goldman, and I'm with the Metropolitan Water District of Southern California, and I'm really honored to be here this morning to moderate this panel on industrial applications. The people that you're going to hear from today are working with companies that are finding solutions to some of our most challenging wastewater issues and water issues in general. And we're going to hear from each of them in just a couple of minutes. First, I just wanted to introduce myself a little bit. I joined Metropolitan's water efficiency team in 2018, and Metropolitan is a large water wholesaler in Southern California. We cover 6 counties in Southern California, and it's a 5,200 mile service area, square mile service area, where we serve about 19 million people drinking water. On the water efficiency team, we help people use water more efficiently. No surprise. But one of the ways that we do that is through incentives. And one of the incentive programs that we have is a performance-based incentive program, the Water Savings Incentive Program. And it's for large projects that are looking at process improvement, and we pay for every 1,000 gallons saved as part of a large industrial project or a project that maybe isn't so specific to a certain technology. But I just say that because I wanted to kind of give you some thoughts to ponder as we listen to our panelists who are going to speak to us today about sustainability and where one man's trash is another man's treasure. I love that theme. You'll also be hearing about how these companies tailor their services to suit their clients' needs and give us some examples to illustrate these things. So we'll also hear about real-time data and remote monitoring. And so I'm just going to let our panelists tell us about how they're working on solutions for wastewater. So first we have Orianna Bretschger. She's the CEO with Aquacycl, and she's going to spend a little bit of time telling us about her company. So Orianna, with that.
Very much, Elise. It's a pleasure to talk to you all today and share a little bit about Aquacycl. So Aquacycl addresses some of these really challenging wastewaters. So what we call ultra high strength wastewaters. Next slide, please. These are going to be wastewaters that are anywhere from 100 times to 1,000 times more concentrated in organic carbon than what you see in a typical city sewer. And so when I say COD and TSS, these things mean chemical oxygen demand or total suspended solid. And that's usually what the city is going to bill against if you're putting anything down the sewer. So you'll be charged per pound of COD and per pound of TSS. The food and beverage companies that we work with generate a lot of this wastewater as a part of their production process. And so right now there are options to discharge to sewer, costing them a lot of money, or they have to haul these wastewaters off-site for land application, which is also extreme cost and not very sustainable. So all of these folks are looking for alternative solutions for both energy savings, water savings, and cost savings throughout the process. Next slide, please. And that's where Aquacycl comes in. So we provide a plug-and-play modular technology that sits on the customer site. We provide a guaranteed compliance against their discharge permits wherever they're residing. And typically, our services will cost them 20 to 60% less than what they're paying now on city surcharge or hauling away. We've already demonstrated the technology with customers like Anheuser-Busch and Mars Wrigley. We just signed a master service agreement with another large food and beverage company. And one of the big advantages that we offer is also a real-time monitoring capacity. So each one of our units is generating a signal, and we capture a measurement of that signal every 5 to 20 minutes. And so we've got a very clear picture of what's happening relative to performance. We can share that with the customer, and it also helps us troubleshoot issues before they become problems in actual treatment. Next slide, please. So this is what the units look like. It's literally a little black box is the bioelectrochemical treatment technology. We use naturally existing bacteria already present in the wastewater that we want to treat or source from the local environment. We bring these bacteria into each one of those reactors, those little black boxes, and those bacteria start to form biofilms or fixed films on the surfaces inside of each reactor. And they start to use those surfaces as a way to breathe or a way to respire. And in that process, they give up electrons. We capture those electrons. We actually generate power in the process, enough power to offset the energy demand of our system, and sometimes, in some cases, be a little bit net energy positive. Now, what we do is we stack these reactors together like Legos inside that shipping container. And a single 40-foot shipping container can treat anywhere from 5,000 to 10,000 gallons a day to a discharge water quality with 90% removal of carbon, depending on what we're treating. What you see in that little round picture there, that's a unit that we built out for a small brewery at Joshua Tree National Park that we actually had the opportunity to work with Elise on. Next slide, please. So some other examples of our installations at a confection, at a brewery, and as well as in Tijuana, Mexico on the far right there. Next slide, please. And just a little bit of data, how we stack up. We're actually able to remove a very significant amount of carbon in a very short period of time. We're able to generate about 1.6 kilowatt hours of power for every kilogram of carbon that we remove. This is about 25% more efficient than a typical anaerobic digester. And we produce the least amount of secondary sludge, which has to haul off site relative to any other technology on the market. Next slide, please. And so when you compare us to other solutions for on-site treatment, we offer the fastest treatment times. We recover energy as DC power. There's no methane, no biogas. We don't generate a lot of extra sludge, so you don't have extra hauling costs. And we do this as a service model. So we're providing wastewater treatment as a service, and there's not a huge capital expenditure to the customer. Next slide, please. So we're always interested to learn more about existing problems and how we might be able to help solve them. So anybody who's got high sugar, high solids, high disposal costs, we want to hear from you. As an early stage company, we're always raising money and seeking partners to work with to expand deployments and further validate the technology. Thanks very much.
You, Orianna. That was great. And yeah, we got to work together. One of the other things that Metropolitan has is a grant program, the Innovative Conservation Program. And Orianna's company applied and won one of those grants years ago. And I got to go out to the brewery and visit. And it was a lot of fun. One of my favorite parts of the job is getting out to the sites. So next we're going to hear from Eric Dole, and he's a senior project manager at Garver, and he's actually their water and energy practice lead. So he's going to talk to us a little bit about what his company's services that his company offers. Eric?
Thank you, Elise. Appreciate it. And thank you, BlueTech, for giving us the opportunity to talk about this research project that we were awarded from the Bureau of Reclamation, where we're treating cooling tower blowdown, which everybody knows is a source of salinity loading in the watershed. And we're basically treating it in a closed loop and creating a byproduct from the residual that we can use to make sodium hypochlorite on site in a circular economy. So I'm going to get started with this. And next slide, please. Talk about the problem, our team, and the solution, which we're calling our pitch. Next slide. So the problem, there's salt. We have a lot of salt, and where does it come from? Well, next slide. Understanding where the salt loading comes from kind of sets the stage for salinity management. This desalination research, we're going to focus on cooling towers, but as you can see here from the yellow lines, salt enters our watershed and our environment from many different places, whether it's ion exchange, spent and regenerate, concentrate from RO systems, water softener brine that's discharged from the homes or the resorts. Chemistry that we add to water and wastewater treatment is typically a metal salt. And then obviously agricultural runoff. That all gets into our watershed, and it impairs our watershed with respect to salt. But we're going to focus on cooling towers. Next slide. One example of cooling towers is power generation. And if you're not familiar with Palo Verde Nuclear Power Plant in West Phoenix, it is the largest nuclear power plant in the country at 4 gigawatts of electricity, and it's the only one in the world that's cooled 100% by treated effluent from 91st Avenue wastewater plant. They have to treat it one more time when it gets on site to remove the other nasties before it's in good enough quality to use in the cooling tower, basically remove all the calcium, magnesium, silicon, phosphate. And they cycle up the cycles of concentration. They use that water over and over again. They use it about 23 to 25 times. So it comes in at like 1,000 TDS and leaves at 25,000 TDS. Next slide. Our team. Next slide. Well, Dr. Mike Mickley, as you can see in the upper left, he is what I call the godfather of brine management. If you can just Google him and you'll find out tons of research papers he's done over his 50-year career. And we're fortunate enough to have him on our team. He's local here in Colorado where the project is going to be staged. We also have Red Rocks Community College, who's going to let us use their cooling tower, 600-ton cooling tower, to perform this pilot test. And then we have some technology providers with Pyle Water and OEMs like Lyons Filter and vacuum-assisted electrodistillation. They're going to help build that system. In the lower right, or in the lower left is, is Dr. Michael Watts, who's our water reuse practice lead for Garver, and I'm the water and energy practice lead. So this is our team. Next slide. Our solution. Next slide. This is a high-level schematic of what we have going on at the cooling tower. You have the 50,000 gallon bath that's used for the recirc water, and it gets blown down at about 2 to 3 cycles of concentration, where it comes down to the sewer at about 2,200 TDS, about 1,200 gallons per day. We're going to capture that blowdown, that's higher TDS, and treat it in our system, right in this closed loop system, where we're going to treat it primarily with electrocoagulation, remove all the divalents and the silica and anything biological that could foul up the membrane system downstream, and then reboost it through a UF system, through GAC, and then RO. And the RO permeate will come back to the cooling tower in a closed loop to promote that water conservation at a lower pH, which is going to increase the health of the water, of the recirc water. And the concentrate is going to be upcycled to about 36,000 ppm TDS. And that's where it's going to get flashed with vacuum-assisted electrodistillation. By that time, all the calcium and magnesium would be out of the brine. It's going to be about 98% sodium chloride. So when we flash it, we're going to use that salt slurry that comes out at about 80% as a feedstock to make on-site sodium hypochlorite that can be used back in the cooling tower to promote a circular economy. Next slide. EC, this is just the theme of this project, this slide here, is it basically, it cleans it pre-treats the water to such a high degree that you're essentially sending the RO a sweeter sauce, we like to call it. And so you can really stress those membranes, push it really hard, and get a high recovery. You have a low flow rate, but a very high TDS concentration that the vacuum-assisted electrodistillation loves. The higher the TDS, the more efficient it is at distilling it. Next slide. This is just some of the bench tests we did for electrocoagulation, where we treated primary clarifier influent from the Height wastewater treatment facility out here in Denver. You can see how well it did in separating the solids, made a beautiful flock. And then the actual, if you go to the next slide, if you focus on the calcium, the hardness basically, the phosphorus and the silica, north of 99% phosphorus removal, 96% silica removal, and almost 70% hardness removal. As we get to a higher pH, you'll get that north of about 95% hardness removal. And we also got a 5-log removal of any fecal that was in that water, just by passing electricity through the brine with the metal electrodes. Next slide. This is what our RO system looks like. It's 2-stage RO. We have a UF, GAC UF gets the pin flock out, GAC removes any chlorine that may be left over so it doesn't hurt the membrane. And then we have a 2-stage membrane. Permeate goes back to the cooling tower, concentrate goes to vacuum-assisted electrodistillation. Next slide. Next slide. There you go. This is what the vacuum-assisted electrodistillation looks like. Right now, it's licensed to recover spent ion exchange from water softeners. It's been tested at about 250,000 ppm TDS and got less than 500 ppm in the distillate at a very low kilowatt hour. There's a video to the right that probably won't play, but what that does is it shows you that at 120,000 ppm spent brine, It was boiling at 114 degrees Fahrenheit under a 28-inch deep vacuum, passing electricity through the brine, and you're getting a distillate of about 60 ppm. That salt slurry that comes out of the bottom, once it flashes below the electrodes, is about 80% by weight, and that's going to be used to feed a microchlor system to create on-site sodium hypochlorite. Next slide. Quickly, if you just tap through this, it shows you how it works, and then that's the final slide. You fill it with the hot brine, you have a cooling water bath, you pass the alternating current through the electrode, it flashes off the steam, goes through the riser tube, condenses on the cold surface, makes distillate, and then out goes a distillate, and the salt slurry drains out the bottom. Next slide. Thank you for the opportunity to present. If you have any questions, I look forward to answering them at the end of this track. Thank you.
Thank you, Eric. And that did please type in the chat. And we will be reading them out at the end of the all the panelists and be able to discuss those questions then. So thank you so much, Eric. That's really interesting. I love hearing about the Palo Verde plant. Matt is the Chief Technical Officer for ClearWater Solutions, and Matt is going to talk to us about his sensor technology and the applications that that they're used. So, Matt.
Thanks very much. Okay, so I'm the CTO at ClearWater Sensors. I come from a background in oceanography. Next slide, please. So we've developed a family of sensors. They provide on-site automated measurements at lab quality, very high resolution, real-time data that can be trusted for process work and a number of applications. It's based on microfluidics, using lab quality analysis on the device. You get very frequent sampling, a few minutes, and this reduces cost compared to having to do sampling typically 10 times versus manual sampling daily, but obviously you're getting a lot more data. You're getting data points every few minutes rather than daily. And the key advantage is that these devices can go anywhere in a catchment or watershed or in the system. They can be submerged. They're very robust. We've deployed over 200 in oceanographic and other applications all around the world. Next slide, please. So these are the parameters that we can measure and how well that we can measure them. So you'll see that the precision and the limits of detection are extremely good. They're as good as the very demanding oceanographic community requires, but the range is also very large and covers many rivers, lakes, and industrial waters. Next slide, please. And they're portable. So there's a slide of one being carried in a very mountainous region. They've been deployed in meltwater streams around glaciers with very turbid water with big chunks of ice in. We've even been able to add antifreezes to the reagents to enable them to work in freezing areas. There's a picture there on the right showing them working in a flooded river, and there's another in a ditch. So very robust instruments that can go literally anywhere in the watershed. And because they're submerged, quite often they're resistant to tampering and the like. Next slide, please. So the data is quite revealing. So on the right, you see some data from phosphate analysis in the River Avon in the UK. And you can see there is this daily cycle. So the dark and light is the days. The blue line is the phosphate. And you can see that the phosphate level is changing with a diurnal signal, which would be completely missed by, say, sampling at the same time every day. And the trends can be different over time. So on the left is a measurement in Empress Dock, which is an estuary area within Southampton. You can see that there can be quite complex changes in chemistry that aren't related to the physical conditions, in this case, seawater salinity. We've deployed these things on vehicles, things like ocean gliders, and that's been very effective for ocean science. Next slide, please. So here's a picture of that deployment on a glider. So the Kongsberg glider, and there are many other gliders that we've worked with. For example, we've deployed on board the Webb Slocum gliders, and it enables a robot to be able to make measurements of chemistry with very, very high quality. And one of the applications in industry for us has been looking at monitoring offshore carbon capture and storage sites. So you can see the chemical signature of a carbon dioxide leak. And we did this with some simulated leaks very accurately. Very small leaks can be spotted, fractions or even a few liters per minute of CO2 released. You can see that in the chemical signature, in that case, the drop in pH. And so it's a very low power sensor, very robust. They can go to 6,000 meters deep. And it means that they can go on long deployments on these low power robotics in the ocean. Next slide, please. But there are a number of non-oceanographic applications, and we've worked with a number of people looking at things like leak detection, wastewater treatment monitoring to see what's happening when you get high rainfall events and you have to release some water. They could be used for industrial pollution management. Mitigation. Recently, there's been a lot of effort to look at reducing the nitrate increase when buildings are put up and development is done. So we can analyze things like reed beds, there's a picture there, to see how efficient nitrate removal or phosphate removal is. And there are a number of other applications. For example, in aquaculture, we can help spot algal blooms and the like before they become a problem by looking at what's happening to the nutrients. Next slide, please. So taking some particular examples, which sensor would be good for some of those? So in aquaculture, if you're trying to look at the quality of the water and look and see whether you're getting a bloom developing, which might need some management, looking at phosphate, nitrate, and silicate will tell you different things about which type of organism is forming. So, for example, silicate may tell you that you've got some diatoms, dinoflagellates, which potentially carry a gene for producing toxins. You can look at nitrate in groundwater, of course, with the nitrate sensor. Wastewater treatment, typically people are looking for phosphate and nitrate. And we've been doing some work looking at mine drainage where iron analysis may be a problem. So that's the sorts of applications those specific sensors have been and could be doing. Next slide, please. And so that's it. So the company is up and running, and there's some information on our website, and please do get in contact if you have any questions.
Thank you, Matt. That was great. Right, I'm just going to jump right into our next presenter, Kurt Tetzlaff. He is the president of WinWerks, and he's going to tell us about the turnkey solutions that they offer for their clients. Kurt?
Thank you, and greetings from San Diego. I'm going to spend a few minutes talking about our value proposition, our electrocoagulation technology, and then move into some of the applications. I would like to thank Eric for doing a great job on the EC presentation, and we've used him in the past to validate some of our solutions. Next, please. Next. So what we've learned over the years after being a developer and a third generation builder is that collaboration really produces much better results than a traditional delivery process where people are working in their individual silos. So our clients basically get a turnkey system where we can design it, build it, operate it, and finance it. And that really takes care of a lot of the internal problems that some companies will have with resources. And so this has been validated in my development career. I've been using it at WinWerks since 2002. Next, please. So we're working in a number of different areas, the coal generation, electrical utilities, cooling towers, various organic and inorganic waste streams, as well as municipal wastewater. The machine that you see there is at a Samsung plant. It's a footprint of a couple of hundred square feet, 600 gallons per minute treatment for heavy metals. Next, please. So electrocoagulation, there's a 4.5-minute video that we have on our website where Scott Powell, the inventor and manufacturer, describes the process very well. You heard about it from Eric also. Basically, I reduce it to we electrocute dirty water clean, and for the price of a couple of kilowatts per 1,000 gallons, we can reduce our total dissolved solids and suspended solids. Tap, please. We kill the pathogens. And what we're trying to do, and using Eric's comments about one person's trash is another's treasure, why throw it away if you can reclaim it? Some of the embedded energy in California it costs over 3,000 kilowatt hours to bring it over from the Colorado River across the mountains and distribute it. We can also clean the water without chemical coagulants or biologics, so we can turn the water very quickly. And one of the inventions that has recently been patented is a combination of microalgae lagoons for primary, secondary treatment plus EC into water discharges. That example with the black to the clear water was coal wash water, a minute of treatment turned it into an industrial grade water. Our footprints from our machines can be anywhere from a few square feet for a 1.5 gallon per minute, or we can take our 600 which is about 400 square feet, and then chain it and do thousands of gallons of water per minute. Next, please. So this is an example of some third-party tests using 1 minute of electrocoagulation. I think at the bottom was really great that less than 1 minute of treatment gets us a log 5 count on the chloroform. And basically these types of constituent removals, we custom make solutions to the water problems that our clients are facing. Next, please. This is an example of Hydro Oklahoma. It's 100,000 gallons a day. It's great for rural America applications where some of the EPA lagoon systems are getting obsolete. To go to a traditional biologic treatment process would be very expensive. We can deliver this for around $4 a treated 1,000 gallons. Run it through the pond, custom-made microalgae. We hit it with EC to kill the final pathogens, and we get EPA discharge. Nominal solids. And the nice thing about these systems is that they work with a switch. You can turn them on, you can turn them off, you can speed them up, you can slow them down. Next, please. I like beer, I have to admit it. And this is a tragedy, I think. It's a $1.5 billion plant that has now been stopped at $900 million in the hole because they can't get a water permit. And they would like to get 8,000 acre feet a year. We made a $57 million proposal to treat their water and their cooling tower water that would reduce their water use from 8,000 acre feet a year to 3,000. Work in progress based on a zero liquid discharge concept. Next, please. This is the train that shows it. We do combine various filtration or clarification systems. There's a picture of some lagoons. It takes about 18 acres for that project. Next, please. This is a project that got me introduced to TMA Blue Tech. I gave a quick presentation one day, and Tamara Khan came up to me and said, "You can make my surfing water clean. We're all for it." Next, please. So what we're looking at here is an incredibly dirty interface between Tijuana, Mexico, and San Diego. It's a 1,700 square mile watershed. And water can come pouring through there on a winter rain event at up to 300 million gallons a day. And you get a lot of trash. The brown bit that you see there comes from a discharge point of 45 million gallons a day. half the year it flows north up to 15 miles and reduces the recreational uses at some of the cities in northern Tijuana, as well as Imperial Beach and Coronado. Next, please. We basically put together a comprehensive system to solve that water problem both north and south of the border. And instead of throwing the water out to sea, we can repurpose it and recover water from 10 to 60 million gallons a day. Next, please. These are some of the examples, but the idea of basically repurposing the water, saving that energy, and using it twice is an incredible opportunity. We've been in conversations with the EPA, the city of Tijuana, as well as the North American Development Bank about this application. Next, please. This one had my wife in tears. There's over 200 square kilometers of wastewater that has a consistency of a chocolate milkshake. The goal is to basically clean up those tar sand pits and turn them into boreal forests. The problem is that the tailing ponds won't have almost neutral buoyancy. They won't consolidate. And what we did was, next please. We basically did some bench scale testing, and we can dewater those fine clay tailings and create a structural base for those forests. We also teamed up with a group out of Canada that will remove the remaining bitumen, and so we can recover water also for the industrial process. Next, please. This is a project we're working on with San Diego State. They're basically 50% of their water is using cooling or irrigation. We can repurpose that water, next please, and turn it into a system where we're using cooling tower blowdown water and getting our cycles of concentration up closer to 45 from 2 or 3, and also distributing the water through the campus. It helps their sustainability goals and saves them money. Next, please. This is where we're proposing to mine sewer water in a 160-acre development. There's an 80-acre park there. We'll basically create Title 22 water using a distributed wastewater treatment concept and put that water on for irrigation. Next, please. That concludes my presentation. I think the electrocoagulation technology is incredibly versatile and can be used in a lot of different places. We really emphasize life cycle costing so that our value propositions are good for 10, 20, 30 years. Next. Thank you.
Thank you, Kurt. And without further ado, we're going to get to our last presenter and then hopefully have a couple of minutes for questions. We have Tristan Walker, who's the Global Business Development Specialist at Deep Trekker. So Tristan.
Good morning, everyone. Thanks, Elise. So as Elise said, I'm Tristan Walker. I'm from Deep Trekker. We are a manufacturer of submersible ROVs, pipe crawlers, and utility vehicles for both clean water and dirty water. Next slide, please. Is there any slides? Fair enough. Okay. Our company is located in Kitchener, Ontario, just outside Toronto. Currently, we have over 50 employees at our head office here in Kitchener, where we manufacture, design, and build the units, and another roughly 10 or so people at our satellite office down in Puerto Montt, Chile. Currently, we're sold in over 100 countries and to many major cities and states across the U.S., including Los Angeles Department of Water and Power, City of Chicago, Atlanta, DC Water, and many more. Some of the major challenges that people face when dealing with drinking water or wastewater is the sheer cost. Clean water is expensive to treat, to store, and to deliver. If you're taking a tank offline for routine inspections and cleaning, you're not only having to discharge all of the spent drinking water from the tank, which has already been cleaned and paid for, but you're also having to worry about rerouting the water from other areas to the nearby communities that you've just disrupted. Having an ROV to complete your inspections and cleaning save thousands of ultimately save thousands of dollars per inspection. Sewage, on the other hand, is severely aging, especially in North America, and in dire need for either replacement or inspection. Being able to prioritize when sewer pipes are being repaired or replaced can save thousands or even hundreds of thousands of dollars in both road closures or repairs. Operations is a large issue that cities face. As our world becomes safer, we're trying to limit the amount of time we have human exposure to dangers like confined spaces or chemicals. So having a routine inspection of these assets is valuable, and you can minimize the risk of contamination of drinking water from sediments and other objects in tanks and whatnot. By using technology to do your inspections, you're able to avoid costly closures to roads, rerouting water, and all the like. You're no longer interrupting the community around you by not having to operate offline and for a set amount of time as well. Now, some of the case studies that we've done, so Clark County in Nevada, they purchased one of our swimming drones a couple of years ago, and we were able to get numbers from the utilities management on the actual savings that they've seen from using our ROVs for their inspections. So currently they have 35 reservoirs, which average just about 650,000 gallons each. They used to take these tanks offline, drain it to be able to do their inspections, which was quite costly and also a major headache for a lot of the communities. On average, these tanks held between $1,600 and $7,500 worth of drinking water that was already cleaned and treated. By using our ROV, they were able to save on average $175,000 a year just from the drain and fills, as well as being able to have the tank, by not having the tank offline and for a cost of manned entry. So what sets us apart from our competitors is the operations of our units. You can pretty much pass our units to any one of your operators, and within a little amount of time, they're able to pick these units up, start operations, and be able to do routine inspections without needing a long learning curve on it. All of our units are completely portable as well, so there's no need for power, topside power, no need for lugging around large equipment. They all come inside of 1 or 2 Pelican cases and can be easily deployed at site. Most importantly, though, all of our units are affordable and will help save you money. They're all built of either cast aluminum, stainless steel, or die-cast acrylics, which can help you tackle the toughest of environments and will allow you to disinfect it before it goes into any drinking water environments. So with that, I thank you for letting me present here. And if there's any questions, I'm sure we'll get to that.
Thank you so much, Tristan. That was great. And you did great even without the slides. I know I learned a lot just from hearing you.
Thanks.
So thank you so much. All right, so we have some questions here. We've got one. What are the special problems of the membrane and how do you tackle the problem of fouling? So maybe we'll, anybody want to jump in and take that question? How do you deal with membrane fouling? Yes, Eric?
Well, the special problems of membrane, you hit it on the head, it is fouling. And if you remove the divalence up front, silica, and the hardness and the silica, that typically is what anti-scalants are used for, then you can increase the recovery, but you're also adding some metal salts to the solution. So if you can do it more passively with electricity and iron electrodes, you not only take out the divalence and the other biological activity like a red algae event that may happen in seawater, you'll what we call nuke the algae, and that will then precipitate out beforehand, so you can essentially send the RO system a much higher purity water and then really stress that membrane to get a higher concentrate recovery. And then the next one is concentrate management. If you can find a cost-effective way to flash that brine, which we're hoping to do with the vacuum-assisted electrodistillation, that can then give you a full circle treatment system, ZLD. So that's all.
Okay. Do we have any other questions from the audience? Okay. Well, thank you so much, everybody, for joining us. And I know each of the panelists would be happy to speak to you more about their technology and services. And you can easily contact them through the WaHova app for the conference. And again, thank you so much for having me. I was very happy to be here. And if you're interested in learning more about water efficiency and industrial incentives,
Thanks.
Thanks everybody
Thank
for
you all.
joining us.
Bye.
Thanks.
Good morning, everybody. Thanks for joining us today, talk some circular economy and water stuff. My name is Cody Harrison, and I'll be doing a little bit of moderation today. I'll give you a quick intro on myself, but really going to try to make the focus today our guest panelists. So again, my name is Cody Harrison. My educational background includes a degree in environmental science and policy from Duke University. And for the last 10 years, I've been working mostly as a project manager in the environmental and social impact sectors generally through an LLC that I started while I was in college. So in that time, I've kind of jumped around a lot in the overall environmental space. I've done some work with water and wastewater was initially what I started on after graduating college, trying to commercialize something on the very high-tech end of the spectrum. It was a technology platform utilizing a genetically enhanced bacteria and a microbial fuel cell to turn wastewater into biogas, electricity, valuable chemicals, things like that. We were not able to ultimately commercialize that technology, but there are similar platforms out there, so that kind of thing is possible. A company called Cambrian Innovations has managed to commercialize a similar technology, so pretty amazing. You can take, there are bacteria in the soil that generate electricity directly from wastewater, and I think that showed me, all the amazing solutions that nature has to offer. She's been doing R&D for a few billion years now, and has come up with some pretty amazing solutions to a lot of the things that humans are struggling with right now. How to shelter ourselves and get things, move goods and services from one place to another, and conserve energy and produce fuels and fibers and all these sorts of things. Nature's been doing for quite a while, so I think there are a lot of solutions to draw from there. Since then, I've played around in regenerative agriculture, sustainable housing. I just finished up about a 3-year gig managing an urban wood salvage project for a local nonprofit. So we were diverting end-of-life trees away from the landfill and getting them in the hands of local sawmill operators as much as possible to turn into lumber. And then looking at other products like wood charcoal for the trees or parts of trees that were not fit for lumber. And there's a huge potential for circularizing that economy. We can grow trees that provide all sorts of ecological and human benefits during their lifetime. And then at end of life, we can utilize them for a variety of beneficial products. You can get a wood oil out of trees that is basically can produce anything that a barrel of petroleum can produce, and not to mention building products and things like that. And now we're gonna switch over to the panelists in just a second here, but I'll give you a little bit of a tease of what we're working on now. So we're trying to pivot the company into something that could be a little bit more scalable and impactful. So we're working to convert it into a stakeholder cooperative and ideally use that as a means to pool resources to take advantage of what we view as another industrial revolution that we're in the early stages of. I think it began with the digital revolution, in the late 90s, early 2000s, which drove the marginal cost of a variety of digital goods and services to near zero, where you could purchase a computer and once you invested that upfront cost, you could produce all this digital content from books, music, magazine articles, all these different things for near zero marginal cost. So once you paid the upfront cost and produced that good, you could then copy it 1 billion times and share it across the world. And the 1,000,000,001st copy of that, it costs no more than the previous and cost, is the cost of electricity basically fractions of a penny to copy that. And the idea was that that would not translate into the physical world. But we think that that's probably going to start happening with things like autonomous vehicles, drones, and you could even make the argument virtual reality, I think, for transportation, the ability to go places digitally and physically through the first two examples may drive the cost of transporting certain goods and services to a near zero marginal cost. Distributed renewables for energy, and then things like 3D printing, robotics, other advanced manufacturing methods for the manufacturing of physical goods. So we want to poise ourselves to be able to take advantage of some of these trends. So 3D printed housing, things like that, I think have a lot of potential to address poverty. And ideally, those things can be produced in a way that's actually ecologically regenerative, so that the more houses you build, actually, creating spaces where, by means of humans occupying those spaces, they actually become more healthy and vibrant. So you can imagine, putting these houses down in a degraded landscape, and a desert, for example, and greening the desert as a result of humans having a presence in that area. So we're actually here on a property in Encinitas, California, where I've been living for a couple of years now, and that I'm living in is set up so that the gray water drains to the landscape and helps support the beautiful vegetation that you see behind me. So that's one example of how that can. I think with that, I'm gonna start to turn it over to the panelists. So we're gonna just go. Yeah, so we're going to Bill Staby first, and I think we're gonna see a presentation from each of our panelists, and then we will do some Q&A. So, Bill, kick it over to you.
Thank you very much, Cody. Can everybody see me here? Good. I will assume yes. Greetings, everybody. Maybe you could put the slides up so that I could get started, and just put the first one up. Do not click on the first slide because it'll trigger a video out of sequence. But well, I'll introduce myself while we work on getting the slides up. I'm Bill Staby. I am speaking to you from Providence, Rhode Island, where I live. Our company, Resolute Marine Energy, is based in Boston, where we are testing our wave-powered desalination system. And we also have a subsidiary in Ireland, effectively, and we have 9 people that work for us in Ireland. That is sort of the center of our project development activities. Introducing Resolute Marine, we've developed a technology which is called Wave 2.0. It harnesses ocean wave energy to produce fresh water. And our target markets are the developing countries and islands, small island developing states. And essentially what we're doing from an environmental benefit perspective is we're displacing diesel-driven desalination systems, which are in wide use worldwide. So could you please click on the first slide? I am going to show a video basically that shows the benefits of what we're doing. I think if you click on the first slide, the video should play.
Earth is indeed the blue planet dominated by water. In fact, water covers over 70% of the planet. But while our water resources may appear limitless, in reality, only 1% of the Earth's water is drinkable, and its distribution is unfair. Today, more than 1 billion people in developing countries and island nations have no access to clean water. And, as a result, a child dies of a water-related disease every 15 seconds. Add to this a rapidly increasing population, exhaustion of our surface water resources, and climate change, and our water problems are only going to get worse. Most of the Earth's water is in the ocean. However, it is undrinkable by humans unless it is desalinated, and this is a costly process that requires lots of energy. However, the ocean is also where one of the cleanest and steadiest sources of energy is located: ocean waves. And that's what we do at Resolute Marine. We use ocean waves to power a desalination system. and provide fresh water for people who really need it. The way it works is simple. First, a flap attached to the bottom of the sea moves back and forth with waves to capture their energy. The energy is converted into pressurized seawater that is sent to the shore where it is filtered through a process called reverse osmosis to produce fresh water. An average plant can produce 4,000 cubic meters per day of fresh water, which is enough to supply the needs of 40,000 people. By displacing fuel consumption that would have otherwise been required, carbon emissions can be reduced by 4,300 tons per year, the equivalent of taking 900 cars off the road. In short, we are developing a breakthrough technology that can help solve the global water crisis by harnessing one of the cleanest and widely available sources of energy, ocean waves.
Okay, could you advance to the next slide, please? So basically, I'm going to run through very quickly so we can get to the circular economy aspects of what we're doing. But we are basically positioning that system in between, right in the middle between household scale solutions and what we call mega scale water production systems. And we, again, as I mentioned, we're displacing diesel generators. Next slide, please. So this is the market. This is where we're working. Our first project is going to be in Cape Verde, probably in the 2022-2023 realm. And we are, again, focused on, you can see Caribbean islands, Pacific islands, Mauritius, there's many islands in Indonesia, etc. So there's a huge market for this particular product that we're developing. Next slide, please. So this is the commercial pilot site in Cape Verde where we're working on the island of São Vicente. And this is the actual site called Praia Grande. And our wave energy converters will be deployed about 100 meters offshore, and the onshore desal plant will be near the bottom base of that mountain that's in the distance. Next slide, please. So this is the timetable for actual commercialization of our technology. We're doing technology validation in our lab space in Hingham, Massachusetts. The next step is to do a series of ocean trials in the Canary Islands at Plocon, a test facility. Next step after that is to do a commercial pilot at the Praia Grande site, which you just saw a picture of. And then finally, in the 2022 to 2025 timeframe, we expect to have 5 plants installed. And each of those plants, to give you an idea of size, would be producing 4,000 cubic meters per day of water, which is enough to supply the drinking water needs of 40,000 people. And when we get to the circular economy slide, you'll see what else that water and the power produced by the system can do. Next slide, please. And here we are. Essentially, the Wave 2.0 machine, which is shown roughly in the middle there, can be used for a variety of different purposes. Number one, of course, is drinking water for human use, and then onwards for food production, and particularly in Cape Verde, intensive agriculture operations, largely in greenhouses. We can service them, so food production is a possibility. Certainly, wastewater treatment is fresh water is an input to that, and then, of course, at a more sort of futuristic realm, the combination of electricity and fresh water production can be used to electrolyze and produce H2 or hydrogen for the upcoming hydrogen economy. So next slide, please. Important to our business model and our corporate culture, if you will, is satisfaction of the United Nations 17 Sustainable Development Goals. We satisfy probably about 9 of them, and this is very important both for who we are as a company, but also for our ability to raise capital down the road. Next slide, which I think is the last slide. Yes, so thank you very much. I hope I'm on time, and anyway, if you want to look at that video again, you can look at the YouTube link is right below. Thank you very much.
Thanks, Bill. That was great. Yeah, really interesting technology there. Looking forward to chatting a little bit more about it. So next we're going to pass it on over to Alan with WaterFleet. And so they produce mobile water infrastructure, really beautiful systems that they're using, and definitely some good potential for the circular economy. Alan, it's all you.
Thank you, Cody. Appreciate it very much. Happy to be on the panel today. Do have a presentation if we can bring that up. So I want to talk to you this morning about WaterFleet's micro utility services, which does create a circular economy for remote locations in the form of water. Next slide, please. It's important to know that at the heart of WaterFleet's mission, we are dedicated to the belief that clean, safe water is a basic human right, even in the most challenging situations. We're obviously in alignment there, Bill, and I'm really excited about what you're doing. Next slide, please. If you looked at WaterFleet at a glance, what you would see is that we're an innovative mobile water and wastewater utility. We operate at remote camps, emergency camps for distressed populations, at industrial construction sites, and also where there are utility needs for even residential. We produce potable water, we clean up wastewater and provide reuse opportunities with it. And of course, along with that, we can create drinking water production and delivery options and workforce relief solutions, which we'll see in a little bit. Next slide, please. The way that we do that as a service is we provide tools out of our toolkit. And one of those tools is the water rig. The water rig is a self-contained proprietary water processing system capable of taking up to very difficult brackish and any kind of contamination in the water and turning it into verifiable potable water that can be distributed throughout a camp. We come as a complete managed service for that, so we can deploy the system and the distribution and provide remote monitoring, maintenance, and testing, etc. with that system. Next slide, please. The second part of our toolkit is to handle the wastewater side. So we do that with a tool called the Reclaimer Rig. Again, a self-contained proprietary system that can process sewage in a remote location and provide a reuse stream back from that. We bring everything needed to set up that collection and send it to our system and then send it to wherever it can be reused. And we can bring and apply your power, our power, your source, our source, etc. Next slide, please. What really, though, creates the advantage for WaterFleet as a service provider is that we have full automation and autonomy of these systems so that they don't need to be manned 24/7, 365 like a typical water or wastewater treatment plant would be. We have full remote monitoring and control with our own proprietary SCADA system called Sonar that can move a lot of data over very small bandwidths, which is really important when you're working in very remote locations. We can then generate a lot of data logging and reporting capability, as well as monitoring for issues and making corrections even remotely. And on top of that, we layer in full compliance capability. So in-house compliance staff, licensed operators, third-party or in-house collection of samples and testing capability, and then regulatory visibility, all included in our service model. Next slide, please. We can bring along some other things that, especially in difficult remote work locations, such as our RECHERCHE solution, which just provides a kiosk-style drinking water distribution system that eliminates the need to move bottled water around for drinking purposes, or that famed orange igloo cooler. Next slide. We can also provide what we call workforce relief. So this is because we can produce water on site that can supply a restroom facility, we can now upgrade the opportunity for people to use a restroom in a more quality of life way than having to use a porta potty. And we can then collect that and process it back to a reuse standard for the site. Next slide. A couple of case studies. So let's think about Pecos, Texas. If you don't know where that is, for all that are listening, it's far west Texas at the border of New Mexico. It's very remote there. We supplied both water and wastewater services to a main camp of about 25 workers living in portable housing for weeks at a time. We were able to take their water source, turn it into the potable water, provide that to the housing and to the workers, collect their sewage, process that sewage back to a reuse standard, and give it back to that drilling operation for their downhole and otherwise industrial activities. What happened because of that is that we eliminated about 3,300 heavy truck miles per month. We produced enough potable water to eliminate the need for bottled water for drinking, and that saved the company about $6,300 a month, and kept a lot of trucks off the road, obviously. The second case study would be a grocery store in Lake Charles, Louisiana. That town was hit very hard by Hurricane Laura this year. We were able to come in, tap into the water from the city that was on boil water notice for nearly a month, process that into verifiable potable water, pressure up the store, and allow it to open to serve the citizens of Lake Charles, not only so that they could come and get food, but also in many cases so that they could use a restroom because they didn't have one, their house had been destroyed. Next slide. Really, if I summed it up, what I would say is what WaterFleet's trying to do is be water as a service in the full water cycle solution. We've built this thing to work in very difficult environments because that's the norm for us. And that reuse opportunity really does promote the opportunity for circular economy, kind of in the same way Bill was talking about all of the ancillary benefits, right, of being able to produce water. It's a proven model. We've done thousands of remote deployments across a good swath of the US. And at the end of the day, what we believe is that safe water equals healthy people and higher productivity. And both of those are important, whether you're a citizen just trying to live or you're a worker trying to work in a very difficult environment. Next slide. That's it. Thanks, Cody.
Beautiful. Yeah, thank you for sharing that. So I think we may be missing our other panelists, but that is okay. That'll just allow us to focus in a little bit more on what both. So do we have any questions coming in from the audience by chance, or should I just, okay. So yeah, I think I'll start it off with a question for Bill. So I'm curious, with your technology, it's doing a direct, it's not converting the wave energy into electricity first, right? It's just using that to directly pressurize the water and run that through the RO system. Is that right?
That's correct, Cody. Yes.
Yeah, I think that's really clever. I just not overcomplicating things, just taking the the form of kinetic energy that's already there and using that.
Well, it's not any less complicated. What it does is it reduces an intermediate step in terms of producing electricity and then having to store it and then having to draw it out once again. You lose efficiency in all of those additional interface steps, basically. So basically what we have created is a purely hydraulic pumping system. Think of our wave energy converters, which are bottom-mounted hinge flaps out in the ocean, simply as wave-driven pumps, and they pump seawater under pressure on shore, which is used to directly drive the RO plant, and also generate some electricity, which is at minimum needed to run the control system, provide security services, all that type of stuff. But if customers need to move water from the storage tank at the end of the process, we can adjust the amount of electricity that's produced. In fact, we can adjust both the amount of water and electricity that's produced according to customer requirements, frankly.
Beautiful. And so in terms of circular opportunity or circular economy opportunities, I'm curious with the salt water that's produced. Are there, I know there are a lot of people looking at deriving, valuable industrial chemicals, things like lithium from seawater. Are you guys seeing any opportunities? I'm sure that's, maybe 5, 10, 15 years out, but is that something you're thinking about? Do you see some value potentially to be captured in that what would usually be considered a waste product?
Sure. So yes, we're part of a DOE-funded project to look into taking concentrated brine solutions and extracting valuable minerals out of it. I I agree with what you said, Cody. It's probably 15, 20 years or more away because the concentrations of those valuable minerals, although they're there in seawater, are so low that you have to produce, huge volumes of water in order to get significant amounts out of it. So it's not really cost effective compared to conventional terrestrial mining operations, unfortunately, because it would be nothing better than to use our brine, stream essentially for benefit. The other things we can do with it, of course, is to pump the brine into evaporation ponds, and that salt product eventually is valuable as well. But the main thing that we're doing, since our systems are relatively small, we're pumping smaller amounts of brine back into the ocean. And of course, one of the big areas of study that we do is to see where that brine outfall is located. And of course, that's we want to be in an area where there's lots of mixing activity from longshore currents or waves or something like that, in order that the plume doesn't settle somewhere and harm the environment. But I just should say that those studies are underway now with funding. We've gotten a very significant amount of funding from the African Development Bank. So the development finance institutions are very interested in what we're doing. So they have funded all of our site characterization work that's going on in Cape Verde now. So
great, thank you for sharing. That's incredible. Switch it over to Alan. So Alan, I'm curious, what is the long-term vision for WaterFleet? Like, where if circular economy ideas continue to gain traction and are hopefully more effectively incentivized, where do you see you guys fitting into the picture? 10 years down the road, what's WaterFleet's future look like?
Yeah, good. Thanks for asking, Cody. I appreciate that. As we expand out into emergency support services, distressed population, work areas where improvements are being made for citizens in the future, wherever that is actually in the world, this mobile, monitored, and capable utility is really the key to making that work. Most often, when people are trying to do things in remote locations, even if it's just living for that matter, the biggest issue is safe water, obviously, and then what happens to the waste. And what's happening with the waste is usually what creates the not safe water situation. So trying to tackle both, I think, simultaneous solution to problems is the way to go, and that's really where we're geared. Yeah, I was actually thinking when Bill was talking about the brine, right? If the opportunity to capture wastewater, get that water, which now is fresh, combined back with concentrated brine reject from an RO, and then discharged back into the ocean, actually is a really good thing for the ocean, right? I mean, there are a number of ways to think about what you do with water that you can capture back from the human cycle. And one of those is to dilute, so that you can give the ocean back what you took from it in reasonably the same shape.
And one, Alan, I'll leverage off of that. Another circular application is actually we can take from a wastewater treatment plant. It's much easier for us to process water from a waste treatment plant. Taking raw seawater and desalinating is very, very difficult. It's very energy intensive. But since there's a higher concentration of fresh water already in wastewater effluent, effectively, it's easier to process. And so one thing that we are looking at is co-locating our systems right next to wastewater treatment plants, coastal wastewater treatment plants. But so that's a circular application right there.
Yeah, and it's happening a lot now, a lot more than people probably realize. Right here in the state of Texas, El Paso is a great example of a direct reuse system that is taking water directly from the wastewater treatment plant and processing it through membrane technology to create water for the city. Again, that's exactly what you're describing, and I think it's a great way to conserve and kind of short circuit the long-winded way that the Earth deals with with taking water and recycling it over a long period of time.
Yeah.
Great. I'm curious, Alan, with your wastewater treatment technologies, are they mostly, I mean, to the extent that you can talk about it and it's not proprietary, are you mostly using membrane technologies, or are any of the systems in a typical wastewater treatment plant present in your systems just kind of miniaturized with like aeration and settling tanks and things like that?
Yeah, it's a good question. We're actually a bit technology agnostic. We want to use the right technology for the right application. When you're moving with a camp very frequently and you're wrap it up and wrap it down, then simpler technologies are the better option in that case. When you have a longer term opportunity where you're trying to get to a much higher level of discharge effluent, and that way I mean that it's cleaner and can be reused for more purposes, then you kind of always want to incorporate membrane at that point. And so we use a combination depending on the application, but I would say primarily with our fleet, we're trying to keep it simple so that it can function appropriately. But if you understand the biological process, you can create really, really amazing effluent by just paying attention. And having our remote monitoring capability and kind of having eyes on all the time without having to stand there is a really helpful thing for us.
Mm-hmm. Great.
I have a question for Alan, if I could.
Yeah, please.
Yeah, so power sources, are you using solar PV panels? Or are you using small wind applications? So what's the full range of things that you've been able to incorporate into your system?
Yeah, so I'll admit that most of the time when we show up somewhere to provide services, someone is providing us power supply in order to do that. And in many cases, especially if it's remote industrial or disaster recovery type situations, it's going to be generated power, diesel generated power. But I think the opportunity absolutely exists for operating these systems off of solar and wind in a more semi-permanent application, or frankly, what you're doing, which I found fascinating and I think is a great opportunity to grab another natural power source, right?
Yeah. Our wave energy converters are not very portable, though. Let's put it that way. We're looking at more sort of permanent installations. Although the Department of Energy has an interesting competition going on called Waves to Water Prize, and it's actually, Alan, it's disaster recovery systems that can be deployed very, very quickly and so on. So we are working on a palletized, very small scale system that can be dropped into the ocean and provide relief very, very quickly, in disaster relief situations. So,
that's awesome.
Yeah. So from the audience, what types of skills are most useful for your workforce development?
Oh, go ahead, Alan.
Yeah. We have a lot of different skill set requirements inside this company, but really at the heart of it, we're trying to serve people that are working out in difficult situations, and actually that puts our people in difficult situations. So agile, okay with working in weather and difficult climate environments, and being able to think outside the box, right? Being clever enough to solve problems when you don't have a lot of resources around you. Those are very, very helpful. But otherwise, overall in our company, I would say we're looking for people to be radically innovative. I went through it pretty quick, but you might have noticed that was one of our core values. And what that means is taking these complex, difficult situations and trying to simplify it as the service offering, right? So we kind of accumulate internally the difficulties, and we turn that into a very simple feeling solution out to the customer. And that takes people who are willing to think outside the box for sure.
Interesting. I can chime in. The skill sets required for for our team members basically are divided into two categories. Our product development team and our project development team, vastly different skills. Well, not vastly, just different skills required in each. On the product development side, as you can imagine, these are hard engineers, essentially doing, CAD drawings, doing a lot of development of control theories and strategies and algorithms and so on and so forth for the overall system. On the project, and they're chemical engineers, mechanical engineers, electrical engineers. We have them all essentially on our side, on the product development side. But on the project development side, we see a few more, I'll call them softer skills, but essentially people experience doing stakeholder outreach type of activities to obtain social license where we're setting up our projects. People that are, skilled in logistics planning and execution, basically getting the project in place. So that's an entirely different set of skills. So that covers sort of the two. Then there's the admin people like myself, and we have those too, frankly.
Oh, I'm sure you're selling yourself short calling yourself an admin person, Bill. So we got a new question. Where do you see the biggest opportunities going forward?
You want to go first again, Alan?
Sure. Well, in the world right now, and for WaterFleet in particular, providing these kinds of services to the emergency response world, and that can go from very short-term things like we did in Lake Charles to very long-term situations where there might be droughts or other climate situations that can last for very long periods of time. That world is very large. If you think about right now what's happening in California, you're there like with the fires. There are thousands of firefighters who are living in pretty difficult conditions while they're doing an extremely difficult job. So I think those kinds of opportunities for us to make the quality of life of those people better while they're having to perform that kind of thing is huge, immediate opportunity that we're trying to get to. Beyond that, we're here talking a little bit about remote islands, and that's really populations that are separated and don't have good utility infrastructure. While we don't do that this second, I think it's a big opportunity, and it's the same as what Bill's talking about doing. I think we're on the same page there.
Yeah, it's for us, it's more the same. I mean, we're really focused on developing countries and islands, if you will. California has water shortages all the time, but they also have a very, very difficult regulatory environment with the California Coastal Commission and so on and so forth. So there's not a huge opportunity for us to develop projects in a reasonable time frame. And of course, the fundamental problem with developing countries and islands is they basically don't have the capital and they don't have the time necessary to build out, large infrastructure projects. And of course, in islands like Cape Verde, which there's 10 of them in that archipelago, it doesn't make any sense. They can't have centralized desalination plants or even electricity generating plants. They have to be distributed around the islands. So this trend that we're taking advantage of, it's not only because the water crisis is getting worse around the world, but even in utility scale electricity production, the transition to distributed assets is definitely a trend that's is happening. So essentially, one of our big selling points, effectively, is we're putting a water production system right next to where the demand is, frankly. So we don't have to, our customers don't have to spend a lot of money on big hydroelectric dams with piping systems and so on and so forth from hundreds of miles away to bring water to their coastal populations, frankly. So it's more the same. There's just, we see, a $10 billion a year market for us, quite frankly, and that's based on water sales. Yeah. So anyway, that's long-winded answer, but lots of opportunity in what we're doing.
No, that was perfect, and that pretty much takes us right to the end of our session. So I want to thank both of our panelists, Bill and Alan. Really appreciate your time and
Thank you, Cody.
Thank you, Cody, and thank you, Alan. It was great to be here.
Pleasure, Bill. Thanks.
Hi, everyone. Thanks for joining us today for this great panel. We're really excited to talk to everybody today about funding opportunities for WaterTech at the Blue Tech Week 2020. I have a great group of panelists here today that's going to present to us. So we're pretty excited. Véronique is going to hear from France, and Sally Gutierrez from EPA, and Rajesh from NSF, and Josh Yeres is here as well. So we're going to go ahead and get started. I believe we have some slides here on my end with Bureau Reclamation, and then we can get started. Oh, that's okay. We'll just go ahead and do it live, like we're used to fixing everything. So for Bureau of Reclamation, we have various funding opportunities as well in the area of water treatment research. And most of the work that we fund has to do with all different kinds of levels of research. So whether it's early on research, you have an idea, you start scale testing, some pilot scale testing, all the way to construction. We actually have programs that can fund the construction facilities, implementing brand new technologies in existing facilities that you want to upgrade to meet either new regulations or to be able to upgrade your facility. So we have all those kinds of programs available that we fund at different levels. The agency is mainly focused on the Western United States. That's kind of our place where we're authorized to do work. We have very little programs that fund nationwide, but we do have some of those. So we do have opportunities east of the Mississippi, but most of them are west of the Mississippi, since that's kind of where our authority lies. Reclamation has been doing work in the area of water treatment and desalination since the 50s with the creation of the Office of Saline Water. So we do have a lot of expertise in the area, and we always are willing to put others that are looking at doing work in this area, whether it's within their own programs, seeking funding through our programs, or utilizing our research facilities that we have available. So we do have those in Arizona, in Yuma. Our desalination facility also has a water quality improvement center where you can do some research. And then our Brackish Groundwater National Desalination Research Facility, which is in Alamogordo, New Mexico. So those facilities are available and open to partners and stakeholders that want to utilize them to do research, pilot testing, or even in some cases, small demonstration tests. So with that, I want to go ahead and get started with our panels. I think I have first here Véronique to go ahead and do her presentation, and I'll hand it off to her.
Yes, thank you very much. Do you have the my PowerPoint? Hello? Yes, wonderful. Thank you very much. Okay, so I'm in charge. I'm the coordinator of the Water Joint Programming Initiative, which is a European initiative, and it exists since 2011. And our vision is water challenges for a changing world. We have actually a team of several people that are listed here, and we are all working on different activities and funding calls. The next slide, please. So here you have an overall of our activities. So we start with our common vision. We implemented a strategic and research and innovation agenda, of course. And we have research funding calls. We have also impact measures. We are doing a lot of knowledge transfer and dissemination towards the public, but also towards stakeholders. Knowledge transfer and dissemination, data observatories and infrastructures, capacity building. We are very well oriented with young researchers and how to train them. Stakeholders involvement, which is very important in the governance of water, and very important, international cooperation, because we are a European initiative with a global outreach. This is the very important aspect of our strategic research agenda. And of course, we're doing some mapping and foresight activities. Next slide, please. So I was talking about this global outreach. Yes, global partnership. We have since 2017, actually, members that are from South Africa, Israel, and other countries. Here you can see the calls that we launched with different countries. So in 2015, we launched a call for proposals with 15 countries and the European Commission, with Israel and South Africa. As you can see, in 2016, we added Canada, Egypt, Taiwan, Tunisia, and Turkey. In 2017, Brazil joined, and 2018, again, different countries, but kind of the same. And very recently, in 2020, we are 27 countries with Brazil, Morocco, South Africa, Taiwan, and Tunisia. And this particular call is on biodiversity and water. The call with 26 countries is aquatic pollutant. And this is the next slide. So here I want to focus on this joint call on aquatic pollutants that was launched in February 2020. And we did it jointly with two other European joint programming initiatives. AMR, antimicrobial resistance, and oceans, which is, of course, also the theme of our Blue Tech Week. So here we are in risks posed by human health and the environment by pollutants and pathogens present in water resources. So these joint calls is asking researchers applying to measure, evaluate, taking actions and strategies to reduce contaminants of emerging concerns, pathogens and antimicrobial resistant bacteria in aquatic ecosystems. 32 funding organizations from 26 countries participated, and we are in the process of inviting 53 full proposals, and out of 184 that had been submitted, and we gathered almost 30 million euros, and you can see the website for this call. So we are at the second step at the moment. Next slide, please. So I would like to widen a little much beyond our funding mechanisms inside the JPI and show you what the EU can bring you as funding tools for innovation in blue economy. In particular, we have the joint programming initiatives that I showed you. You might be interested by, of course, ours, water, fresh water, and oceans, but also by a call that is open to SMEs, EU SMEs, but also from outside Europe, if you have an added value. And the call will be closed on the 16th of February 2021. So you can contact your European partners and answer to that call. We're going to have the European Horizon Europe, for the next framework program called Horizon Europe 2021 until 2027. And under Horizon Europe, we're going to have the European Innovation Council and other tools, in particular a tool called Partnership that we are going to use for water, and we do hope to obtain the money to open different calls in water. And our next vision for water, it's water for all, security for water for all. So secure water is our vision. And of course, we are going to have a European partnership with a global outreach, and we do hope to collaborate and partner with you within the Blue Tech Week and United States, and also beyond, like other countries. And finally, last slide. So this is, the Water Europe, the specific tools for identifying partners, very important. You have the European Technology and Innovation Platform for Ocean Energy, where you can have brokerage, and Water Europe. And finally, the last slide, which is about more information, we are on Twitter, we are on LinkedIn. Please don't hesitate to contact me, to contact the Secretariat. You saw we are about 8 people, and we're here to serve the water. Thank you.
Thank you, Véronique. That's really interesting. So we'll go ahead and go to our next presenter, and then we'll complete presentations, and then we'll come back for questions and discussion. So Sally, do you want to go ahead and get started?
Sure. Thanks, Yuliana. And thank you to Michael Jones. There should be a presentation coming up. Yes, thank you to Michael Jones for his continuing leadership in the water cluster there in San Diego, and Tamara Khan for inviting me to be part of this event today. And I'd like to give you just a quick look at some of the ways that EPA is supporting water technology and innovation. Many times EPA is viewed as just a regulator, but I can tell you that there is just so much more to that story. If we can go to the next slide. First and foremost, we are happy to be one of the 11 federal agencies that administer the Small Business Innovation Research Program. This is a competitive, proposal-driven program that provides funding to promising early-stage innovative technology companies, including those in water. I always say that this is some of the best money out there. This is non-dilutive capital. Nice. You can see that there are 2 phases, and we start at a very high-risk type of construct in phase 1, and the more serious money is in phase 2. Water topics, I can tell you, are part of the annual solicitation in every year. So we have water topics. So some of the ones we've had in the past were monitoring and treatment technology for water reuse, sampling devices for microplastics, PFAS destruction, rehabilitation of water infrastructure, and water sensor technology. We have a listserv that you can sign up for to keep you in the loop on upcoming solicitations. So please sign up. If we can go to the next slide, please. I'd like to also talk about our university-based research grants. So in addition to the SBIR program, we also administer a competitive grant program, and eligible entities include universities, nonprofit organizations, and this research supplements our in-house research. Solicitations come out periodically on a variety of topics that are of high interest to the agency. The current and open solicitations that we have, one is on viral pathogen and surrogate approaches for assessing and improving risk-based treatment performance in water reuse application. And you can see the application date on that, and then evaluation of pollutants in biosolids. We have a couple of upcoming solicitations, so these have not yet been released, but it gives you a peek into the future. Water technology innovation, water infrastructure, and water reuse. We're competing that as a cooperative agreement. And then also there is one coming on facilitating multi-state adoption of innovative treatment technologies for very small drinking water systems. And if you just Google EPA water research grants or go to grants.gov, you can get more information. We can go to the next slide. So another way that EPA research can support innovative water technology development is through partnerships. And like other federal laboratories, we have an amazing brain trust. And under our Federal Technology Transfer Authority, we can partner with the private sector and other academics to develop new technologies or improve on already developed technologies. So we do this under a mechanism that we call the Cooperative Research and Development Agreements. And the great part about these types of agreements is that we do not have to compete them. We just kind of find the right relationship that where our research priorities align, and we can move forward. As a part of that, once the intellectual property is developed, the partner gets the first rights to the intellectual property for licensing and commercialization. We can't provide funding under this mechanism, but we can join forces using our own resources. So it's really a quite nice arrangement. And additionally, our researchers do patent inventions, and those are also available to partners who want to license them out. So we have on our website a list of all of the current patents that we have that are available. And finally, if we can go to the last slide, I wanted to mention innovative technology opportunities within the agency's responsibilities on water infrastructure finance. So these are funds that go to utilities and other water and wastewater system owners, and they are for improving water infrastructure. And those take the form primarily of the state revolving loan fund programs for drinking water and wastewater, and also our water infrastructure finance. And these are big monies, billions of dollars that go out under these programs. But when we think about them, these are the opportunities that we can say will drive the market. And we really encourage innovative technologies to be part of these overall loans that are provided to the utility industry. Thank you again for the opportunity to provide these remarks.
Thank you, Sally. We'll go to our next presenter, Rajesh. You want to go ahead and get started?
Yeah, thank you. Can I have my slide, please? First of all, thank you, Sally, because you talked about the SBIR program. So you already kind of teed up what I'm going to say. I'm talking about NSF SBIR program, and we actually have been branding ourselves as America's Seed Fund. Basically, our annual budget is about $200 million, and we fund close to 350 companies every year. And all we do is provide grant. It's not contract, so it's really non-dilutive funding again. But NSF is not the ultimate recipient of the technology. So we are actually topic agnostic in the sense that we fund all sorts of interesting ideas, but those ideas must meet our requirements of the merit. And the requirements are basically three: that the idea has to be technically very innovative and must carry a very high technical risk. We do not fund low risk ideas which may be having pretty high rewards, but we really want to encourage risk taking. So we specifically look for high technical risk ideas. And then those ideas, if they pan out, they should have significant commercial and societal impact. There is a very strong focus in our program on commercialization. So even at the earliest stage, we like companies to talk about how they are thinking about commercializing the technology. Obviously, technical innovation and technical risk are table stakes for our program, but we do want to know whether the companies have actually thought through how that's going to become a sustainable business. We are very friendly to startups. Almost 3/4 of the companies that we fund have not received a single dollar from federal government in terms of developing the technology. The average size of our company is about 3 people, and almost 90% of the companies have started come into existence in last 5 years. So because we are topic agnostic, anything in blue tech is obviously welcome. I personally manage a segment of the portfolio, environmental technology, and I do have topics related to water and conservation and ocean and so forth. So anybody who is interested in, please take a look at it. Look at our website, seedfund.nsf.gov, and it has a pretty extensive amount of information. Our process is pretty fluid. It's a two-step process. First step is you submit your idea in a 2-page project pitch. There is a Google form on our website, and we guarantee that we'll respond to you within 3 weeks. And if you are invited to submit the full proposal, then there is a 15-page proposal that you can submit anytime. We actually are open to receive project pitches and full proposals throughout the year. For the sake of managing the logistics, we describe windows for submitting it, and it's once every 3 months. So basically, it's an open call on any topic, as long as those topics are very, and the problems and the solutions are very innovative and high impact. And phase 1, we provide $256,000, and company can spend it over 6 to 12 months. And phase 2 is about $1 million. And then in phase 2, we have a lot of interesting supplements, which can add up to a significant amount of money. One major one is phase 2B, where if the company accumulates enough revenues or attracts qualified outside investment, we will match 50 cents on the dollar up to $500,000. So essentially, a company can expect to receive up to $1.75 million in non-dilutive grant in a stage-wise fashion, and have access to NSF resources and a lot of other activities we do to help company actually become successful in the marketplace. I'll stop here and hopefully have some questions that I can answer later on. Thank you.
That's a lot of money. So with that, we'll go ahead with Josh. If you could go ahead and get started.
Sure. Good morning to you all. Yeah, thank you very much for my slides. So over here where we are on the other side of the lake in Israel, it's already nighttime, but thank you so much to the TMA team for inviting me after getting to know each other back in 2016 back in San Diego. Michael, Tamara, and Melissa. It's very, very interesting. The speakers before me, a lot of information. I am trying to give my point of view from my experiences several years ago when I was running the innovation in Jerusalem's municipal water utility. And now that I'm assisting companies of all sizes and bandwidth to achieve funding, as we said, grant funding or non-equity non-diluting equity for funding. So let's move on to the next slide. The challenges that I identified, so we've identified over the years regarding the water sector in specifics, is the fact that it's a very conservative sector. We've heard very often the saying, if it's not broken, why fix it? The long development period requiring for the innovations involved in this sector, and the gaps between the laboratory and also the real life. Based upon those problems, the solution that we propose or that we see is relevant, and I also presented it in the part of the report that I co-authored for the World Bank, as you see on the side there, is creating an enabling environment for water innovation. And these have three segments. First of all, what I call the triangle of innovation. Also, the importance, and I say this again, assuming that in the audience, they're not only technology companies, but they're also stakeholders who are utilities and also large companies. The importance of using the utilities as partners in the innovation development process. And the last one is to maximize the use of grant funding for companies of all sizes and along the whole range of company and technology development. Next slide, please. Just in short, the triangle of innovation, as I call it, points out that we have three sides. Obviously, there's the tech companies. We have financing entities, whether it be corporate or government. But I believed, and what we did in Jerusalem was the basis of using the utilities as implementation sites and being places where the ideas could be tested and further developed, and then usually act as partners for the go-to-market potential. Next slide, please. Again, this is a slide that I've taken from the Israeli Innovation Authority, and it shows the types of financing for high-tech companies throughout the life cycle. What I want to impress upon everyone here, and what I truly believe in, is that grant funding is relevant in all stages. And I see this also often, I'm sure Véronique sees that also in Europe, where the largest corporations and also the SMEs just starting are enjoying and utilizing and leveraging funding available. And this is something which I really believe in and highly support. Next slide, please. When I approach companies, in order to achieve that, based upon the various funding opportunities, we have to match the TRL, technology readiness level, of the technology that is being developed in the company, even if there's several different technologies, and match that to the various calls and funding opportunities in order to achieve a match and make the roadmap for the funding. Yes, next slide. And this is my last slide. The result is what we have here is a ocean of funding opportunities, and I really do believe in the importance of funding opportunities and grants cross-border. And that's it. And please, any questions?
Thank you. That's very nice visuals about TRLs and kind of where research lands and what we all mean by research. It is in all places, I agree, from the very beginning all the way to even when you already have something and it's not working the way it's supposed to be, you still have to do some more research to fix it. So
Right.
I do agree with that mentality that grants should be used all along the way and not just at the beginning. Great. Let me go ahead and look at those questions. And how can the public help to support investment in these types of technologies? Does Sally or Rajesh want to take that as you work in the public sector in a way?
Yeah, I can speak perhaps in that I think that the public has become much more supportive and able. You know, I think about platforms like GoFundMe and so much that can happen. And I know companies, a lot of them or some of them will use platforms like that to allow just a broad set of supporters to come into play, just anybody and everybody, someone who's interested in that.
Yeah, I would add that public can also support if they find that some of the companies that are funded are actually delivering great results. They should write to their Congress people and tell them that this is actually making an impact. That's a very nice way of actually showing that the whole circle is virtuous.
Great. And this is a question about how can public education help your field? So I think, Véronique, you had a pretty interesting collaboration across so many different countries. Do you want to take a stab at how you think public education helps this field in the area of water?
Yes, I can. I mean, public education, you mean that's like not university.
Right, like
Public
the
education
outreach you
means
have to do to inform the public of kind of what's happening for them to
okay,
understand why
okay,
you're making
okay. So
investments.
it can go up to university because we are more into, of course, training. Yes, the field of water needs, and actually it's pretty well done in Europe, uh, needs education, capacity building in water. And what we need and what we are doing inside the water JPI is also to do capacity building also in governance, water management, sustainable sustainable water management. And we had a very interesting knowledge hub, and it's actually running. This knowledge hub is gathering all we can improve the UN Sustainable Development Goals. And within this knowledge hub, we have, of course, researchers, but we have also capacity building.
Great. Josh, anything you would like to add on that question from your expertise?
Well, public education is important, and it's. I think from my point of view, is the fact that at the end, in order to have the innovation, so people have to have a realistic look of what can be done, but also should push their local stakeholders. We've seen in many utilities there is, as I said in one of my slides, there is a suspicion of new technologies. And I think, therefore, this is where the public can come forward and push the stakeholders, the local utilities, in order to urge them to be a little risky, because there are a lot of innovation that has proven itself and has done a lot of good in the many areas that we're talking about. And that is something that the public should assist in and to push them to move the sector ahead.
Right, that's a great segue to the next question. Where do you see the greatest opportunities in terms of all of your programs? I think that's a great question. You all work in very different little niches in a way within this sector. So where do you see these greatest opportunities come up? We can start with you, Rajesh.
Okay, I would say that one area that I see a lot of activity is reducing the use of water in agriculture. And particularly in this COVID climate, people have become aware of the supply chain breakage and how people are struggling sometimes with empty grocery shelves. So there is a huge interest in vertical farming, where you can actually have very high productivity with very low level of input. But that's just one example. There is also a lot of I don't know, opportunity in terms of commercial opportunity, but tremendous need is in the preservation of coral reefs and maintaining resilience of the shorelines for the cities. So these are all big topic areas where there are a lot of ideas and opportunities.
Yep. Anyone else have something to share on greatest opportunities? Yeah, Josh.
Right. I just wanted to jump in here. I really wanted to support what I believe is a great opportunity is the potential of cross-border projects. And we heard my other panel members discuss, Elise, Sally, and Rajesh spoke about U.S. Targeted, and also you in the beginning related to U.S. targeted projects. And I want to put my vote together with Véronique in the ability to go and the importance of cross-border. Obviously, the EU has many. Israel, as an associated country, participates, I would say, in almost all of the European frameworks. Israel and United States. There's also the BIRD, Bird Foundation, and there is a lot of opportunity in finding partners out of your box across the borders, and to do something 1 + 1 can be 3. And therefore, that is something which I've seen very often, and the companies, large and small, I don't want to go into the list of my clients, but very, very large companies and also small companies were able to find partners overseas and achieve amazing things. So this is something, and the frameworks are there. I could only hope there could be more frameworks that would be able to support that.
Véronique,
if I
you had
may,
something on that?
Yes.
Oh, sorry.
Yes. Yes, I would say even that 1 + 1 can be 11. So that's even. But I totally agree with you, Josh. No, to answer the question, I'm thinking about circular economy. I really think that circular economy to approach to wastewater treatment plants and also developing and implementing fit-for-use concept for water-dependent sectors. And that I think is really important. Yeah, Rajesh?
Yeah, I also wanted to say that actually, NSF invests significant amount of money in food, water, energy nexus, and there are a lot of interesting opportunities, both in terms of academic research as well as through SBIR program solutions that can actually move the needle.
Yeah.
If I could
So,
can I just one last moment issue regarding what Rajesh mentioned before about reusing effluent. I can't pass by the opportunity to point out the fact that Israel has achieved, I believe, 85% of reuse of the effluent for agriculture. So again, here going back to the cross-border innovation concept, we're more than happy. And I see the question on the bottom there regarding Latin America. Well, for Israeli companies, there is now a Israeli Brazil call. But that is something which might be relevant for that. So.
yeah. So now that you've mentioned the next question, in terms of funding available for Latin America, Mexico, I'll take a stab a little bit on that, specifically within reclamation. Within the DWPR program, we do have funding available for U.S.-Mexico partnerships to do work in water, desalination, obviously, San Diego, taking advantage sometimes in those partnerships because water doesn't know borders, really, and we are just this big land mass here where water flows. So we do have the ability to provide funding. We don't get a lot of applications. Actually, I don't think I've gotten an application in the last 4 years, and the need is there. But sometimes people don't understand kind of how these funding capabilities are available, and so we like these opportunities that WaterTech offers and others to be able to provide this information to everybody. But if you are interested into that funding, let me know, and you can send me a chat through the WaterTech system, and I can catch up with you if you're interested to know more about that. But from the rest of the panelists, I know there's different programs that we all have in terms of providing funding for non-US entities, whether they're just near the south border or north border or across the pond over there in the European Union. Does anybody else have something else to add to that? Sally, Rajesh, Véronique?
Yeah. One thing I wanted to say that although we are funding only US-based companies, we don't tell them where their markets are. So many of our companies are actually approaching global markets. I have a company in my portfolio that is exclusively trying to provide drinking water in Bangladesh. Is another one that is working in Peru. So US-based companies who are willing to go and find the opportunities wherever on the globe, we fund them.
And Josh, you showed in your slide a very interesting European program, which is called Eureka. and Eurostar, which is very, very much funding like 45 countries. So I cannot count them. But first, there are European countries, but we are not 45 European countries, only 27. So there are many more countries involved. So you can go back to Josh's slide.
I just want to just
ahead,
one
Josh.
remark. I know that the session is referring to water, but my slides were relevant, and I'm sure that many of the other slides also presented were relevant to almost every other sector. And as Véronique mentioned, ocean activity, technology, renewable energy, everything. So at the end of the day, this is, I believe, again, what should be done and what can be done. Companies, stakeholders of all sizes should leverage. There's this funding out there, and it's a pity not to use it. And it's just more. It's more than the funding. It's the collaboration. It's the connection. It's the market penetration. It is so much more than the money.
The platform, yeah, definitely.
So our next question we have here is, what types of workforce development will help this field? I know, Sally, you work with so many different people all over outside of EPA and within EPA. Would you like to take a little stab at that one in terms of workforce development?
Yeah, of course. And over the last, I would say, 18 months, the agency has really focused a lot of attention on water workforce. We actually have a website and have been really trying to understand the needs, because the water industry in the US is getting quite advanced, and we need to attract, kind of this new generation, and it's really a very pertinent topic, because we have to really make wastewater treatment and wastewater reuse, right, really attractive to data scientists, and so we're competing with other very prominent industrial sectors, but we need these folks to carry our water industry forward. So I think for those universities and other workforce development participants on this webinar, we need the workers. We need a new generation of workers to really take over this industry for the country. And I would encourage everyone to look at the work that we've done on water workforce at EPA and give us your feedback and more support in that.
Yes, Josh.
The question, Sally, I almost forgotten what to say about this, but then what you just said took me back several years ago when I was working at the Jerusalem utility. And the issue that we had there, I mean, technology, water today is GIS, is IoT, is big data, and the problem we had was we had these wonderful technologies that we had in the network, and the person who was there for 15, 20 years, he was used to getting a phone call to tell him there was a leak somewhere or a burst pipe. And we had to try to tell them that, when you come to your office in the morning, turn on your computer and, go onto this GIS, and you can see already where the burst pipes are. You don't have to wait for the phone call. So this was part of the whole state of mind and the mindset that had to be changed. And so I agree with you 100%. The monetary remuneration for the officials, for the professionals in the utilities, has to be such that will attract people, because the systems have gone by far, and the people sometimes have to realize we're in a new world.
Yeah. And we're running out of time, so Véronique, something real quick before we close.
Just quickly, we need also multidisciplinary workforce. We need people understanding health, understanding water, understanding, the soil. We need multidisciplinary workforce. That's it.
Great. Thank you so much, everyone.
We're okay
So
with
it's
5
great
more
to have
minutes.
everyone.
Yeah, 5 more minutes.
Oh, 5 more minutes? Oh, perfect.
Wow.
Okay,
I was like, oh, God, we're
perfect.
gonna run out of. So, that
Great.
was a great question. Actually, I do think that's needed. It gives me time to thank everybody for participating in this webinar talking about funding opportunities for WaterTech. We want to thank everybody, all the sponsors that make Blue Tech Week possible, especially in this virtual
Yeah.
format that we find ourselves. This also makes it very interesting because I would have never probably met Véronique or Josh that are all across the other
Yes,
side of the world. And it's
exactly.
an opportunity. So
It's
I'm
dark
thankful
here.
for that. And that
Well,
I'm
thank you for
sure
a great moderation.
yeah.
Thank you for a great moderation, Yuliana. Thanks.
Well,
Thumbs
thank you,
up.
everyone. Thank you so
And
much.
thank you for Michael,
Right. Thank
and
you.
Tamara,
Thank
and
you.
Melissa. Thank
Thank
you.
you. Thank you.
Good afternoon. Welcome to our panel on Blue Tech during Blue Tech Week on accelerators, incubators, and clusters. We have a very exciting panel here today from all over the world. I will just start off by talking a little bit about the role of accelerators, incubators, and clusters are really nodes across the world that provide services and support for innovators to come through and get business advice at times, sometimes funding, different types of access to technology support, lab, and so forth. And just to kick this off with a little bit of background about myself, we get the slide up. My name is Evie Holst. I am from the Cleveland Water Alliance, Director of Clusters and Innovation. Next slide, please. Cleveland Water Alliance is based in Cleveland, Ohio. We are on Lake Erie, which is one of the 5 Great Lakes that make up about 20% of the world's freshwater surface area. And we actually work with the state and all around the region of the Great Lakes and Lake Erie in particular. Next slide, please. So we're located, sorry, I gotta get into my camera here. We've got a range of different things about our background specifically. So some of you would know our area, Cleveland, as being, you know, one of the places where the river caught fire in the late 60s, and it's pretty much equivalent with the birth of the Clean Water Act. And as a result of that, it turns out this region has a really strong legacy of water industry expertise. We have some 300 or more water solutions companies in the region. We have very forward-thinking public utilities, and together they combine for about 16,000 jobs in Northeast Ohio, adding about 300 net new blue economy jobs every year. The water industry here in Northeast Ohio is actually one of the fastest growing sectors of the state. It's outpacing advanced manufacturing and aerospace and biohealth, which is a pretty big deal when you think about the fact that we have the Cleveland Clinic here and a range of really top line healthcare centers. Wastewater and water utilities in this region spend about $500 million a year to improve efficiency and lower their costs. So there's a lot of opportunity for innovation to work its way into that infrastructure. And our port is also one of the more robust in the Great Lakes region, with direct connections through the St. Lawrence Seaway to Europe. Next slide, please. So, you know, we're really facing a new generation of challenges, and some of these are very salient here in the region and then across the world, of course. So we're facing with algal toxins and corroding infrastructure, certainly lead pipes with our neighbors here in Michigan to the north of us. And our innovation is really anchored around some of these key areas where we're seeing some growth. Next slide, please. So just to give you an idea of some of our core programming, we are an industry-driven cluster. We have some significant brands within the industry that are part of our membership. We just landed a $1.6 million grant from the Economic Development Administration, specifically focused on our expansion of open innovation programming, as well as some test bed development here. We have smart sensing pilots. We're working with the state on agricultural runoff, and we have some various IoT related projects for making a smart lake here on Lake Erie. Next slide, please. So recently we also were chosen as a regional top bet, is what they're calling it, basically looking at advanced manufacturing and healthcare as investable areas for our regional economic endeavors. And the water economy is one of those top bets that our regional partners are making. And that includes the development of a seed fund for us to put towards new innovations, some additional open innovation programming, as I mentioned before, also some talent development. Next slide, please. Just a glimpse of some of our partners. We really have a very broad reach with foundations and public sector institutions, as well as private sector companies that are providing us with access to resources, funding, as well as some of those innovation trial points that we'll be developing further with our testbed efforts. Next slide, please. So that's me, and that's the Cleveland Water Alliance, and I look forward to introducing my panelists here. That concludes my part. So just to introduce a few of our panelists, let me start out with Laetitia Amiot. Laetitia has a master's degree in economic development and attended the London School of Economics and Political Science, as well as the Sorbonne in Paris. She has extensive experience in innovation projects, has TBT International in a range of roles since 2011. Laetitia, I understand TBT Innovation is a French innovation business center and economic development agency working to unlock growth and innovation potential with a positive impact. Can you tell us more about it?
Yes, thank you. I'm really glad to be here and to be able to what we do. I'll get my camera. Great. So as Abby just said, we are the Economic Development Agency of Toulon, Provence, Méditerranée. So you'll know I'm French. Next slide, please. I'll show you where we are. We are located in France, in the south of France, right next to the Mediterranean Sea. We are an innovation hub with very good connection on the South European side, really close to Italy and Spain, and also well connected with Paris and the Mediterranean areas because of our location. Next slide, please. As you can see, we are here as an economic development agency to really try to foster our territorial marketing and to invest in the international promotion of our activities. We have a strong economic key sectors we try to promote in the sense of making it more sustainable, fostering innovation to become more sustainable. I'll show you and I'll explain the different sectors we work on. We support also the innovation ecosystem with both public and private stakeholders, R&D centers, incubators, and our different clusters that we work with, like, for example, the Sea Business Cluster, which is the Pôle Mer, and we try to create international events. I'll come with more details on that later on. Next slide, please. I wanted to just present briefly the economic sectors we focus on. Of course, blue economy, because we are located next to the Mediterranean Sea. Defensive security, since we are the first military harbor in France and on the Mediterranean Sea. the 4.0 industries, as we have a strong cluster called System Factory working on high-tech innovation technologies, creative industries with maybe you heard about it, the French tech national network we are part of, and silver economy and smart tech to work on smart cities and new sustainable high-tech development and startups. Next slide, please. That's the focus on blue economy. Of course, it was linked to today, and I wanted to showcase our resources on that with the fact that we are the first military naval base in France. We have a big maritime techno park and the first international French maritime innovation business cluster called the Pôle Mer Méditerranée. We both work with naval and civil authorities, which brings me to my next slide, which is everything that links to defense and security. This is very important for us. We work a lot with the Navy on innovation and defense. Yeah. And yes, and on the everything that concerns maritime aeronautics and space. We have a strong focus on cybersecurity also. With work we do with our digital cluster. Next slide, please. Of course, tourism, I just wanted to show you that we have a very strong French tourism sector in Toulon, Provence, Méditerranée, where we also have very interesting international business opportunities, and we hope you'll be able to come one day and see it after this COVID crisis. Next one, please. What we do to support innovation, we have a digital and innovation center with a co-working space and business incubators. We also have an open innovation platform and industry-focused cluster to support the development of partnerships between startups and major companies. Next slide, please. Have innovation labs, user-centered for the SMEs, but also a city lab and learning labs for our higher degree organization. And we just opened our creative and knowledge district just a couple of weeks ago. Next slide. This is the save the date. We're going to have a big event in May, hopefully next year, linked to everything that links digital and innovation technologies. It is called the Murex Festival. We'll have a professional exhibition with a marketplace dedicated to innovation startups, and then we'll have seminars and conferences. Next slide, please. This is also what we do to promote soft lending, help international networks for our SMEs to go abroad, but also for any companies that wants to land, soft land in France. And then it's a good gateway, we think, for the Mediterranean area and for Europe. Next slide, please. There we go, our members and our funders, and the last one, please, on the slide will be my contacts. If you need anything, any information on what we do, and if we can help you in your international development in France and Europe. Thank you very much.
I think I'm here.
I'm so glad to hear about what your team has been up to, and I think I hear Philip.
Yes, I'm
Philip?
here. I'm having issue with my camera, but I'm here live and listening and ready.
Okay. So we have Philip. No visuals for Philip. But let me just give a brief introduction here to Philip, and I'll let you talk. So prior to Okay, I'm sorry, we still have to troubleshoot with Phil. So let me move on to Dr. Gisle Nondal. He's Manager of Research and Development at GCE Ocean Technology. Dr. Nondal joined GCE Ocean Technology as R&D Manager in 2016. He holds a PhD in Chemical Oceanography from the University of Virgin and has held several research positions within ocean science. Prior to joining the cluster, Dr. Nondal served as Senior HSE Manager at Aker Solutions, subsea facility in Norway. GCE Ocean Technology is an industry-driven cluster with ocean technology with more than 120 partners and members. Gisle, could you tell us more about it?
Yes, I can. Thank you very much for the very nice introduction. So if you move to the next slide, I will start talking around our members and our partners. So it's quite a busy slide, but it's to highlight all the different companies and their logos and the members and partners in the cluster. So as you can see on the left-hand side, we have divided these members and partners into 5 stakeholder categories. It has to do with our innovation ecosystem, where we believe that, or through actually a R&D program with MIT, in the US, that if you have the corporates working together with the entrepreneurs, the capital and investors, the academic and institutes and R&D sectors together with the government, then we have an optimal ecosystem for innovation. So it's about what was introduced, about 130 different companies, and we have the entire value chain from the small suppliers to the big leading Norwegian locomotives also operating internationally. I forgot to say, but I'm based on the west coast of Norway. Just had to change tires on my car this morning. The snow has arrived, so that's the status report from Bergen. So if you move to the next slide, I will talk a little bit about our scope and what we do in the cluster. So if you look at the picture on the bottom left, you can see the scale also kind of highlights our focus areas. So we have a long tradition in Norway and on the western coast of doing subsea and underwater technology. It has, of course, to do with the oil and gas industry, which we are still involved in, but we are now seeing a lot of potential to use this technology also into new markets. So our competence base comes from the oil and gas, but we are now moving into emerging markets like especially floating offshore wind, marine exposed offshore food production. We have companies also working within marine mineral, both detection, but further down the road also to harvest these minerals. And we have a very strong cluster base that is based around what we call a smart ocean. And there are also initiatives in Europe. We're talking about the digital twin of the ocean. So it all has to do with measurement science, both for climate, underwater assets, and environmental monitoring. On the right-hand side is our strategy. So we would like to take our share, or to help our companies to take out the big potential that's estimated by OECD going forward to 2030. Then the ocean industries should double their impact on the global economy. So we need to, of course, help them to achieve that. At the same time, we need, of course, to focus on the sustainability issues. We have the climate problems, we have the Paris Agreement, and all of these things that is, of course, our license to operate. So we need to balance the potential to take out more value from the ocean. At the same time, we need to do it in a sustainable manner. So if you take the next slide, I will go briefly through our services. So these are all activities that are, of course, targeted towards our members and our partners. We have a quite extensive international network. We are partners in the BlueTech Cluster Alliance that I know that TMA BlueTech was one of the founding clusters from. So we are really happy about that long-lasting collaboration that we have going on. So I'm really pleased to be there, although I should have been physically in the US, but unfortunately we couldn't do that, of course, as you know. So the network is important. We connect the companies with other clusters, other companies, other R&D institutes. We have quite a big portfolio when it comes to competence and training. We provide a lot of courses and events for the clusters where they can learn from either other members, or we can teach them lean manufacturing and all of these things that they need to evolve. Several projects, working groups. I will show one example at the end on that. We also spend quite a lot of time providing innovation advice. The Norwegian governmental support structure is very good. We are governmentally funded also in the cluster, but it's very, very complicated to find the right support structure for your own companies. That's why we are helping the companies navigate in this public support jungle. Business development programs, we have quite a few of those targeted towards both startups, scale-up companies that has the potential to grow. We also help them to move into new markets. So we have had several companies moving from 100% business in oil and gas to now diversifying into, for example, offshore seafood farming. Events, we have about 50 events in a normal year. It has been a little bit reduced this year, of course, but it's an important part of what we do is to create these meeting places. And last but not least is the marketing effect of being a part of cluster. When we participate in any conference or anywhere in the world, we always bring up the first slide I had with the logos to show that the cluster is exactly that. It's the companies, it's the members. We are a facilitator, but it's the ingredients are all those logos. So then you can take the next slide, please. So I will show one example before I end, what we call crossover activity. That is to do with this technology transfer and the technology shift, that I was talking about. We want to take oil and gas technology, know-how, competence, and move into new markets. So if you take the next slide, I have what at least I think is a very interesting example that's going on in Norway these days. It's called the Deep Purple Project. And what this has to do is to, a part of the green shift, we want to produce hydrogen, which we again can use as a fuel for both automotive industry, but in this case targeted towards the maritime and the shipping industry. So the concept here is to use floating offshore wind farms, offshore windmills to produce electricity, and then the electricity is again used for electrolysis to produce hydrogen. And the trick is also to include an element of subsea storage. So you have actually a subsea storage system that you can use to distribute hydrogen to either oil and gas facilities, to ships and other end users. So that's just one of many examples I could have shown, but I think I'll leave it at that. And thank you very much.
Thank you so much. It's great to hear all the different things that you're up to there. We're going to move on next to Aidan Thorne from the National Oceanography Center. In May 2018, Aidan became the manager of the Knox Marine Robotics Innovation Center. He has 19 years of experience for the NOC, largely in industry-facing roles, primarily focused around the center's technology-related work. He's worked with industry, academic, and government partners to secure funding for collaborative R&D projects, as well as commissioned research work for the NOC. The NOC Innovation Center accelerates exploitation of UK investment in marine autonomous technology through collaborative solutions to solve the key challenges in the ocean economy. Aidan, tell us more about what you're working on.
Thank you very much for that, Ebby. Thank you. Can you hear me? Good. Good morning, everybody. Afternoon or evening, depending on where you're attending from today. Thank you very much to TMA BlueTech for the opportunity to speak to you and for an excellent few days of talks so far. As Ebby says, I'm Aidan Thorne. I'm the manager of the UK's National Oceanography Centre's Marine Robotics Innovation Centre down on the south coast in Southampton. Hopefully some of you have been there before for things like ocean business or other opportunities, but yeah, we're down there on the south coast. As Ebby says, it's a centre that accelerates the exploitation of the UK investment in autonomous technology through collaborative solutions to solve the key challenges in the ocean economy. The NOC is the UK's leading research institution for marine science and technology development, and our main mission is to make sense of changing seas, upon which the future of human prosperity and well-being depends. Towards that mission, the NOC has been developing for over 20 years and deploying marine autonomous systems. And so in November of 2015, in fact, it's our 5th birthday next week, the Marine Robotics Innovation Centre was launched. This was a £3 million investment by the UK government, as the Chancellor at the time, George Osborne's, part of his 8 Great Technology initiative. So robotics was one of those initiatives there that he announced, and yeah, we got the funding through that. Next slide, please. Since we launched, we have had a total of 37 partners, from startup micros to large multinationals, and we've worked with many of these partners to develop projects that have had a total value of around £20 million. We're also working with them to develop this value proposition, and rather than read the whole thing, I just want to pick a few key points for you. We're a community, and that community is a true leveler in terms of the voice of the partners. It's a centre that facilitates opportunities for partners of all sizes and types to engage with each other on a peer-to-peer level. We're collaborative. We seek to encourage partnerships to satisfy funding calls or end-user needs, and we like it if the NOC is involved in those collaborations too, but it's not a requirement. We do encourage partners to collaborate with each other, not necessarily always with the NOC in those partnerships. We engage key stakeholders. We have an external advisory group and members from government organisation and funding organisations, academia, end users. So we've got the likes of the UK MOD and oil and gas end users as part of that external advisory group and as members of the Innovation Centre. We run regular seminars and webinars and workshops dedicated meetings, so that partners can discuss their technologies and work out how they might collaborate. Next slide, please. So I know we're up against it for time this evening, or sorry, this morning for most of you, but and each one of these pictures is probably a 20-minute presentation in itself, so I won't be doing that now. But if anyone would like to hear more about any of the topics that the Innovation Centre is covering, please do find me in the event networking session for BlueTech, and I'm happy to talk to you further. Hopefully you've already heard about the EcoSub story from our partners Planet Ocean during their presentation yesterday. This is a great story of collaboration, from initial concept to market research to R&D programs, end user engagement, and then taking that product to the marketplace. And this was all facilitated along their journey, really, by the Innovation Centre. But we also get involved with projects around things like regulation of marine autonomous systems. And in the top corner, you can see a group of NOC partners, NOC Innovation Centre partners there on board a Royal Navy ship during last year's London International Shipping Week, at a time when we were all had to stand a bit closer to each other and actually meet face to face. These are partners from industry and government that were engaged in a program called Marine Autonomous Regulation Lab, or MARLab. And this was led by our Innovation Centre partners, the Maritime and Coast Guard Agency, and hosted out of the NOC's Innovation Centre. Next slide, please. Finally, I just thought I'd want to show you a slide that highlights the access and exposure that we provide to our partners. Because NOC is a world leader in oceanographic research centre, we are regularly on the touring routes for key people, including government ministers, government departments such as the Department for International Trade, Department for Transport, and other such organisations like that. We're on the touring route for national and international research organisations, end user communities. So, for example, the picture that you can see in the top corner is with the wave glider in it, is an international oil spill response group that we hosted last year. And of course, we have regular visits from the UK Navy. And as this is a US conference, I also put a picture there of a visit from one of the US Navy visitors there as well. So that's it from me. Thank you very much. As I say, do reach out and speak to me in the event networking sessions if you want to hear more about any of those projects.
Aidan, thank you so much for giving us that overview. It's too bad that we don't have more time to go deeper on these various initiatives, but I need to turn it over to Philip LeBlanc. We have back online. Bill is the innovation facilitator at the Port of San Diego, California. And prior to his work at the Port of San Diego, Bill was co-founder and chief innovation officer of AMSAT Corporation and managed key research initiatives for Arctic Memorial Universities. Bill has a master's degree in environmental science from Université Laval, and he has been with the port since 2016. Bill, I understand the Port of San Diego established a blue economy incubator to act as a launching pad for sustainable aquaculture, as well as port-related blue tech ventures. Can you tell us a little bit more about that?
With pleasure. Thanks, Abby, for the introduction, and thanks for the panelists. It's a pleasure to be here. So, what I wanted to contribute to the discussion today is demonstrate how port can act as a catalyst to support entrepreneurship and launch innovation in a port context. So, moving on to the next slide. Quick context here for the presentation. The Port of San Diego is a public agency established by the state of California. Here, the slide is showing the jurisdiction of the Port of San Diego. In orange, the tidelands, and also the submerged tidelands. Moving on to the next slide, the Port of San Diego has a very diverse portfolio of businesses and responsibilities, promoting economical development in San Diego, but also responsible for environmental stewardship. So, and I won't go into the details of what's in the portfolio, but it's from marine terminal for cargo, for cruise terminals. We have 22 parks, hotels, over hundreds of lease. So it's quite of a diverse portfolio of businesses. And moving on, within that context, on the next slide, what the port wanted to create back in 2015 is a program to explore new opportunities within the maritime sector. To help diversify this portfolio. So we've been exploring new opportunities for the district to invest in emerging industries of aquaculture and blue tech, showing here. So industries such as environmental remediation, marine clean tech, aquaculture. And on the next slide, specifically for aquaculture, we see this as a tool for a port for various of things like education and outreach, bioremediation, fisheries enhancement. So the port took a stand in 2015 to act to provide a leadership role to grow the aquaculture in San Diego. But moving on to what I wanted to talk about, just a quick context first. But on the next slide, what we established in 2016 is a Blue Economy Incubator, which focused on providing entrepreneur and innovator with pilot project facilitation tools. So we provide subject matter expertise from the different departments at the port. We help with permit-ready infrastructure, market access, and funding. So our role there with the incubator is we wanted to remove barriers to entrepreneur and enable innovation to take place in a port environment. So provide early-stage companies the opportunity to come and work with the port to demonstrate either their prototype of a new technology or a new business model. So moving on to the next slide. What we have is an unrolling call for proposals. So companies can engage with the Port of San Diego, send us a proposal, and that proposal is the basis of our review. We conduct extensive due diligence process to make sure that the proposal aligns with the mission of the port, has multiple co-benefits for the region, and help us address a challenge that we face as a port. So the next slide shows our competitive review process. It's a 4-step process. I won't bore you with the details, but if companies are interested in reaching out to us, it can take 6 months to a year to be in front of our board for a recommendation for approval of a pilot project. So the next slide shows the incubator portfolio that we built in the last 4 years. Oh, before I wanted to just talk that it's a port-wide collaboration process from due diligence to installation and involves all subject matter experts at the port. So it really is a port-wide collaboration process. The next slide will show the incubator portfolio. So it's a wide range of company we supported and pilot project that we helped launch, from smart marine operation software to growing shellfish in the bay. So next, if we can go 5 seconds per slide, let's go through. I wanted to take you on a virtual tour around the bay, but we don't have much time. But this is one of the pilot projects, What Advantage. Moving on to the next slide. So a company that work with the port to build a minimum viable product of a software to optimize marine operation. Next slide is for San Diego Bay Aquaculture. It was a 5-year pilot project for a company to demonstrate that its shellfish aquaculture is feasible in San Diego Bay and sustainable. The next slide shows the company. So the company in operation, they actually grow shellfish in the bay using a floating upweller nursery system technology. So the port invested in that project for 5 years to help the company obtain the permit to operate shellfish operation in San Diego Bay. The next slide shows how well the oysters are growing, grew like in a flopsy. So we have a competitive advantage in San Diego Bay with our water being warm and rich in nutrients. And as you see at the bottom of the picture, it's a nursery stage of shellfish aquaculture. So growing the oysters from the size of a pepper flake to the size of a quarter. Next slide, it's a company called Seaweed Aquaculture. We funded a 2-year pilot project to demonstrate the feasibility of seaweed aquaculture in San Diego Bay. The next slide shows what the port provided in terms of support, access to a lab for the company to establish their hatchery. And the next slide shows the location in San Diego Bay that we provided. And as you can see here, is different lines of seaweed, different type of seaweed grown at different depth. For the project, the company is growing different species for different market and monitoring over the time of the project their results. So a really interesting pilot project. Next, we have a Retonder, which is a boat wash company from Sweden. What they provided the pilot project is for 2 years to demonstrate an alternative to in-water oil cleaning. So here's the schematic of the boat wash. Boat gets in and then it gets cleaned mechanically by brushes that rotate and go back and forth. So it's kind of an alternative to current practices. Divers now clean the hull of the boat in San Diego Bay. In each boat, the hulls of the boats are painted with copper-based paint, so that creates pollution issue over time. So this project addressed this specific issue, which is complementary to ongoing program at the port to reduce copper in the water. The next slide shows the pilot in action. We've been testing for water quality during the cleaning with the boat wash and also with the divers to compare, and been testing different filtration system to collect the copper over time. So very interesting pilot project that is ongoing. Next one is the marine debris removal. It's a completed pilot project. 1 year, a company came to demonstrate a new vessel type to skim and remove debris from San Diego Bay. Here we show pictures of all the different kind of debris. 33,000 pounds of debris were collected during the pilot, and the company helped build a database of hotspots around the bay where trash accumulate the most. So a very successful pilot. The company was able to get a contract with the port afterwards to continue skimming and providing that services. Next projects are ongoing that are about to be deployed. EcoSpear will be in San Diego Bay in December to deploy their SBIR technology, which is an in-situ technology to remove contaminants from the sediment. So it's a schematic here on this slide showing how the technology works. It's a spin-off from NASA lab. The company has exclusive license of the technology. The next slide shows what the project will look like in deployment. So basically the company, instead of dredging or capping, push spears, as you see on the slide here, spears into the sediments, and over time collects the contaminants. And then after a few months of deployment, the company removed those spears and the contaminants are destroyed. So very interesting pilot project, again, addressing the challenge we face as a port. And finally, I wanted to highlight eConcrete, which is the latest of the pilot project approved by the port. It's for a 2-year project for the company to demonstrate their bioenhancing concrete solution. Here's a picture of the new design of their technology. So they're going to build 72 units of those tide pools. And on the next slide, you'll see they're going to create a tide pool system which will mimic typical coastal environments that attract biodiversity on the coastline. So it would be interesting to monitor this project for 2 years to see how it increases biodiversity on the coastline, or how it protects for sea level impact. So a very interesting pilot project is about to launch. So I wanted to give you a tour, give you some visual, but this summarized my presentation. But Really, our focus is on providing pilot project facilitation for early stage company and being complementary into the region as part of the ecosystem. Thanks for your time.
Phil, thanks so much for giving us a little bit of a deep dive there. We're going to be really tight on time, but we've seen some. We're the last panel, I understand, so we're able to take a little more time if we need to. So far we've seen some presentations on existing incubator, cluster, accelerator programs, but now we're going to talk a little bit about one that's more about gathering data in the run-up to establishing one of these types of programs. Chris Ward is the principal consultant at Delaware Consulting, where he focuses on providing strategy, marketing, and business development services for organizations serving the water, maritime, and marine oceanographic industries. Chris was formerly part of the executive team of Xylem, was also a NOAA commissioned officer, NOAA, and has worked with YSI, Sontec, and Andorra Data Instruments, where he built quite a career. Delaware Consulting, as I understand it, Chris, is has been involved in 2 incubator cluster accelerator efforts to help define blue tech related innovation center programs for both Seattle and San Diego. Can you tell us a little bit about that?
Great, thank you for the introduction, and I'll try to go through it pretty quickly. As AB said, this is about a outreach process for defining your innovation center. If you go next slide, please. And it's really about, at your starting point 0, so you want to have an innovation center in your region. What do you do? Who do you want to support it? How do you get the information to support it? And the answer to that is, well, an outreach program can really help to inform all the above so that when you come up with your plan, it will be more readily accepted by the community. Next slide, please. So as Ivy was saying, this is really a tale of 2 cities, and this just happened to be a program that came up in Seattle that in 2017, right when I was starting my consulting business, where TMA BlueTech was asked by the Port of Seattle to help them define an innovation center, a maritime innovation center for the Seattle area. And so I contracted with TMA BlueTech along with Eco Northwest, and we put a program together. And then similarly in San Diego, there were some events with a new Blue Campus, which is part of our redevelopment downtown, where Scripps Institute of Oceanography, part of UC San Diego, was asked to do something similar. And so I was contracted for them, along again with Eco Northwest, to put together a package recommending what to do with such a program. Next slide, please. The starting point is, it's a very fragmented area, as you all know. You got to really make a list of what your givens are. What are the real important things that your sponsor wants to accomplish, or who are the really important stakeholders you need to reach out to. Next slide, please. So the considerations you put in, this is pretty much the 6-step process we went through, and sort of the timeline at the bottom. Now I have a slide on each of these, so I won't go into it, but we started with putting together a list, ran a series of workshops, conducted outreaching and benchmarking all along, and finished up with an online survey and a data synthesis. Next slide, please. So the first part of the process, which is where you have a contact list, is it's actually overlooked. It was actually very difficult when you all get your teams together and you say, okay, who are we going to reach out to? There wasn't a good pool of good data, like in a CRM format, that you could just automatically, do a program with. So we spent a lot of time at the beginning just trying to assemble a list into an information system that we could use to embark upon the process. And in this process, we also ended up segmenting the list into different groups, and Seattle's groups were slightly different than what San Diego's groups were. And this is just basically on the interest of the project and the sponsors. Next slide, please. Early in the process, we held workshops they took on a little bit different flavors in Seattle as opposed to San Diego. It was a more important component of the Seattle project, and we had, I didn't have the count, but it was at least 75, maybe 100 people attended all the workshops we did. And because Seattle is regionally diverse, we ended up doing it in several of the regions around Seattle, up in Anacortes, out at Port Haddock, and Bremerton. Each one of those had its own outreach workshop where we physically went and did presentations and met one-on-one with a lot of folks. Whereas in San Diego, this format took, we did 2 workshops at Scripps. It was a little bit easier to accomplish. Ended up with 32 people over the course of 2 days. And in both cases, though, what we'd recommend is we used a professional facilitator and very structured program. And the idea was to get a consensus from divergent stakeholders. So you're not getting individual opinions. Everybody's got their own selfish opinions when it comes to these things. The idea of the workshop is drive towards getting the group to agree so that at the end you can say, yeah, we all agreed upon this, and that would feed the stakeholder outreach process. Next slide, please. The outreach interviews, this is the most time-intensive part of it. This is where hand-picked one-on-one interviews were done with people, not only within the region, but around the world who would have influence on the process. And I think this probably drove the most rich part of the content that was actually used in the end for the recommendations. We did a lot more of them on the San Diego project. I think just because we were sharper after doing Seattle and learning about the process, I think we weighted this a little bit heavier when I came around to doing the San Diego. I just want to point it right. We actually went through a lengthy process of reducing the data of, listing out everybody's main points and just tearing them down one by one till we got, consensus within each segment, within each market segment of each group. Next slide, please. One of the last parts of the process was putting together an online survey, and this is a relatively I won't say it's easy to do, but by the time you get to this, you kind of know where the whole process is heading. And so this is used to validate where you think it's going. And also the other important part that this does is drive some of the quantitative numbers you need. Like we want to know how big does the center need to be, or really specific details where, numbers driven stuff is helpful to the final answer. I'll also add that a lot of the stakeholders, the primary stakeholders or sponsors really like the online survey because they have quantitative data. They can put a report, look, 35% of people said they wanted this. And that's great, but it is real important in the lead up to this online survey that this survey has been informed by the other aspects of the project so that you know what you're asking and you're getting the right data back that you think is going to be meaningful to everybody else. Again, this is also garbage in, garbage out. It can be highly biased by your pool. So, if you end up having a recipient list that has 5,000 people in a particular segment that is a little bit adjacent to the area, that can sway your data. So that needs to be reduced at the end. Again, we did this in a professional format. In both cases, Eco Northwest put together this and used logic. So it was very professionally done and a real important part of the process. Next slide, please. So benchmarking, this is another really important part. This is maybe one of the most fun parts. I personally really enjoyed this and learned a lot from doing it. And a number of my fellow panelists here I even talked to as part of the project. And we were able to use all the stuff we did in Seattle to inform the San Diego project. So we were able to have a head start. But a couple I just want to point out that we didn't just look at blue tech incubators. We looked far and wide for things that had similar aspects. So like in the case of Seattle, they had a building that they were renovating that they wanted to be the center point of the center. And so we went and found an incubator program that had a similar building that they renovated. So that's why we looked at New Lab in New York, because they had an old Navy shipbuilding building that they wanted to renovate and be the innovation center. So that was an important thing to look at. Well, what were all the aspects of that? What were the challenges and unique aspects of having a historic building turned into an innovation center? In the case of San Diego, some of the unique attributes was that it was going to be right in downtown in a deep commercial area with expensive real estate and everything else. And what are the individual challenges around that? And that was really hard to find one that was similar, but Georgia Tech Center in Atlanta is, a downtown, innovation center with all the bells and whistles around it. So that's one we benchmarked specifically for Georgia Tech Center. But for each one, we probably looked at least 20 different centers of both blue tech and biotech and other sorts of innovation, just so that we got a good cross section. Next slide, please. So, just in sum, this talk wasn't really about the specifics of what came out of the Seattle and San Diego project. It was more about how the process informed the final decision making. And it's really about that mix of having workshops, personal interviews, leading to an online survey, and then compiling all that data so that it makes sense to the sponsors who want to put this innovation center in the first place. Next slide, please. And if you do want more information, the Seattle report, the Maritime Center at Fisherman's Terminal, that report is publicly available online. The link is there if you want the link. It's a very long link, so if you want it afterwards, just let me know and I'll send it to you. The San Diego effort is still under negotiation. There was a final report written. It was for internal use by the University of San Diego. However, if you're interested, we can put you in touch with Vanessa Scott over at Scripps, and she'd be happy to talk to you about what the present status of that project is. So so I guess that pulls up the rear, and hope that was quick.
Chris, thank you so much for providing us that overview. I want to just first ask, since we are a little bit over time, but we've got a few more minutes, whether or not there are some questions. Let's see, how can incubators and accelerators work together? This is a great question. I'm going to throw this to you, Letitia. Tell us a little bit about how you coordinate with other incubators or clusters.
So we do in our local ecosystem, as we are in the same buildings, for example, we have an innovation center where you can find both the incubators with the R&D projects in them and the accelerator programs. They are located in the same place, which enables people to connect easier. And it's a faster way, it's a faster track to get people on this faster pace for innovative projects. So that's something we do, but in our local ecosystem, and then to try to get beyond our ecosystem, we connect with our different European partners inside European projects where we have dedicated accelerator programs to get linked, and then with international cooperation, very specific on our key economic sectors.
Great, thank you. There are a couple of things that I've come across about how different clusters can work together over the last several years. And one was when a hurricane hit Houston, Texas, and the cluster there actually leveraged a call for technologies to help them deal with disaster response. So they, it was essentially treated the network, the players that were clusters across the U.S. as a network to respond. And I know that I've heard some interest in having a way to use different clusters from around the world to accelerate market entry. Dr. Nandal, your thoughts on that, and what have you come across?
Yes, I was just thinking about that, and I think for us it's very important that we are part of these global alliances. Then we have cluster partners in other countries, so we can kind of put our companies in their direction if they're looking for a market entry in that market. So on that respect, I could highlight what TMA BlueTech is doing with their BlueTech Global Connect webinars, where we have had members from our cluster in Norway and Iceland that have been introduced to the US market. So I think these strategic alliances are really important. And also what was mentioned before, we also have alliances with accelerator networks also globally. So I think the network and the ability to connect your companies with relevant hosts in other countries is key for us.
Great. And Phil, I see you nodding your head. What are your thoughts on how different organizations work together?
Yeah, I agree with what was said. For us, we we partner with other accelerator in different region. The goal is to share pipeline and to create opportunities for early stage company, right? So where we fit in the stage of development of a company might be different to another accelerator or another partner that we have in our ecosystem. So we try to make people aware of where we fit and what the opportunity is. And we have a lot of case where companies came to us from different on the East Coast, for example, from Cove, which is very interesting. The Center for Ocean Entrepreneurship there in Halifax. They have a lot in common with San Diego Bay, but cold water. We have hot weather, and different kind of industry here. So some of their companies there are interested in piloting their technology with us in San Diego. So just one example. And regionally, we partner with a different accelerator and incubator in the region to create more opportunities for local companies and innovator coming from outside. So it's about sharing pipeline and being open to that collaboration, innovation mindset.
I think one of the so tell me, Aiden, if you can, what do you think of as the skills necessary for workforce development in this industry?
So I think from our perspective, we're working quite closely on this with a group in the Solent region where Southampton is the maritime enterprise zone, and we're looking at a lot at that skills development piece. And I think it's an evolving picture. I think from our perspective, we're looking more at the autonomy side of things, obviously, and we're seeing evolving skills now are needed in terms of programmers and computer scientists and things like that. Whereas years ago, when I first started at the NOC, we were looking at broadly kind of mechanical engineers and things like that. But now we've got a whole kind of software team based in the innovation center there, and we're looking at, in terms of autonomy, remote operation centers and things like that. So there's a shift in terms of the skills that are needed now.
I've seen a similar trend as well. Certainly in the United States, we talk a lot about the aging workforce within the utilities, but I certainly also have been seeing a shift towards the high-tech IoT end of things. Do any of you have any specific thoughts that mirror that, or something a little bit different?
Well, I can sort of comment on that. That kind of came up in both the projects I worked on, and that both of the sponsor organizations were really interested in trying to draw youth into the programs, and particularly tech workers. And how do you make the whole program attractive for that, right? So they were trying to use the physical assets they had. In the case of Seattle, they had this historic fisheries building at the Fisherman's Terminal, and how do they connect that to the culture in Seattle, which has Amazon and Microsoft and all these sorts of things. So that was a big aspect of that project. And in San Diego, similarly, we got this downtown location that's right at Seaport Village with a big aquarium planned for it. A lot of people are going to see this sort of thing that don't normally see it, right? So can that be used as a leveraging arm to attract people to the industry or to particular jobs that have to do with maritime oceanography? So those are both really big aspects of both projects. Is how do you attract new workers? How do you make maritime blue ocean exciting so that the next generation of people will want to engage in careers there?
Well, thank you, all of you, for your thoughts here. I do wish we had more time. The one thing I want to say to our audience here is that you're seeing in front of you some really great resources for you on your journey as you're innovating products and solutions for the water industry. And please, hunt each of us down and find out how you can take advantage of some of the supports we have here. And as we're wrapping up here, I just want to say that starting at 12:45 Pacific time, there is an after hours event. So as we close out here, please visit the agenda and choose that after hours event to join in. And we want to thank everyone for joining us, the panelists and our hosts. And we look forward to providing support in the months and years ahead. Thank you.
Thank you.
Bye-bye.
Hi, thanks for joining us for our water wastewater track. I'm Tamara, program manager, and as we're wrapping up on this track early, I encourage you to go to one of the other tracks. There's some really great programming continuing, and as EB was kind enough to let you know, on the agenda, we'll be having some after hours meetup at 12:45. We'd love you guys to participate. It's been an adventure transferring this Blue Tech Week to virtual, and I'm sure many people have seen sometimes we have glitches, but we appreciate you sticking with us and getting as much out of our programming that we worked so hard to bring you. So thanks, and we look forward to seeing you a little later.